Ladies and gentlemen, colleagues, good afternoon, and you're very much welcome at this session in the afternoon of the first day of the SEEP conference 2025. And we are really pleased and honored to start the final event of the iWAYS project. I think we have been looking at what is next in terms of circularity this morning, and we'll keep on working on circularity also in the afternoon with a tangible example, an emblematic example given by the iWAYS project, which is a project funded by the European Union under Horizon 2020 framework program from research and innovation. Now, this project is slowly phasing out with great results, and at the same time, today, we're going to have important speakers that will give us insights on several aspects of water and energy challenges in industrial environments. At the same time, also, we have the opportunity to host new projects that can build on the legacy of the iWAYS projects, which are projects funded by A.SPIRE, Process for Planet, public-private partnership with the European Commission. I myself today, I'm representing Water Europe as a proud partner of the iWAYS project and as a representative of the partnership A.SPIRE and Processes for Planet. So welcome. I hope that you will enjoy the session and the speakers as well. And then I leave the floor to Elmar for some additional intro words.
Yeah, thank you very much. Just a couple of words from me. I'm Elmar Bartlmae from the European Science Communication Institute, and we have been following the iWAYS project and also the previous project ETEKINA, and trying to make sure that the message that we want to give to you today is about technologies, about all these things, that they are not only technically important, but they also convey an important message. So we think always a little bit about what is the meaning of what's happening there. And just one example, we put on the table some of the final brochure that we just printed out last week. So that's brand new about this project, and where you can also take with you and have a reminder of it. But now I think we should start. You're going to introduce the next speaker.
I will. So, the first speaker, it is Geoff Townsend from Ecolab. Geoff is an industry fellow in Ecolab and is also the chair of the Committee of Practice of Water Smart Industry. So, Geoff, I'd like to ask you to join us here and to give your presentation. Thank you.
Hopefully you can hear me. Well, thank you. Thank you, Andrea. Very good afternoon to you. I always have a speaking slot straight after lunch, and I've learned it's really hard to compete with carbohydrates. So I hope you're fairly well caffeinated for the next 15 minutes. I want to talk about accelerating the industrial circularity transition for a water smart economy and society. And it's a really big topic for 15 minutes, and I can only hope to fly over the top of it and relay some of the key elements of this. But central to a water smart society, and certainly core to our identity as Water Europe, is the value of water. And that in itself is a really challenging and complex topic. And even though, as you demonstrated on the slide here, there's some very fundamental aspects to this around water security, resilience. In Europe, you'll probably be aware they just recently released a water resilience strategy, and it's gaining a lot of attention. And also this whole concept of sustainable water use and what that means. And to have sustainable water use, we need to understand that water is local, it's finite, and it's a shared resource. And unless we embrace that complexity, we will not achieve sustainable water use. In fact, that describes really our journey over the last 10 to 15 years, a huge amount of awareness and activity, but limited impact. Okay, so we need to really be real about these fundamental challenges. And I would argue that not adequately valuing water is one of the greatest hindrances to accelerating industrial circularity. Now, we know as water becomes more scarce, the value of water far exceeds its price. And we also may be aware that across Europe, for example, there's an inverse relationship between scarcity and price. The highest unit price is in Copenhagen. The lowest unit price is in southern Greece, and I don't need to tell you which is the most water scarce area. So there are these fundamental challenges associated with this. We also have a significant difference in the way that water is valued at the local level between different stakeholders, which also makes it very, very complex. And that also underlines this last point on the slide, how important it is to have effective governance at that local level. When it comes to industry, we see a very different dynamic emerging. And that is that on the left-hand side, you see the interrelationship between energy intensity and water intensity. It's on a log scale. So the more energy intensive an industry is, typically the more water intensive it becomes. And there's no surprise there, because water is the predominant energy transfer medium that sits at the heart of industry. Anywhere between 35 and 75% of total energy, including electric energy, is transferred at some point through water. So the water energy nexus is a concept we're all very familiar with, but we need to go beyond that when we talk about circularity, to really add this additional word, productivity, and really get to the heart of the water energy productivity nexus. And you'll see in that tetrahedron on the top right, the important connections that are there, and to understand those and the dynamics that exist, and to quantify these, and to do that very effectively. And the reason that's so important is that water has its greatest economic value the very moment it's transferring energy at the heart of production. Whether that's energy production or steel production, wherever it might be, at the moment that water's transferring energy and producing something, that the value at that second or two is incredibly high. And we need to understand that. And we need to understand that in terms of the relationship with energy and emissions and competitiveness, and especially to use the latest and best digital applications that are available to us now, and particularly digital twins and the value they can provide. And if we applied a digital twin to an ethylene plant in Germany, and just by understanding what it is to produce more for the same emissions or vice versa, we could see the pathway through water, through the lens of water, to produce $25 million more ethylene for the same emissions. So these are really big impacts once you start following water at the heart of production in these very energy intensive processes. So how do we accelerate industrial circularity? Well, again, really big topic. So these are just some really basic concepts. The first is tie circularity to competitiveness. Once there's a misalignment between those two concepts, things tend to go downhill pretty quickly. And in fact, I spend a lot of time supporting the European Commission, and the word I hear more than any other in Brussels is competitiveness, right? And how that's tied to productivity. And of course, energy and water are really foundational to that productivity and those requirements. And then we need to focus on outcomes. What are we trying to achieve, truly achieve, and maybe the business models associated with those outcomes. And then what insights do we need to deliver on those outcomes? Often I see an industry working the other way around. Well, we have this data available, and let's see what we can do with this in terms of an outcome. No, we need to be really disciplined on focusing on the really important outcomes, and then making sure that we have the insights to support those. And then perhaps a little bit provocatively, when you look at the three pillars of sustainability, obviously the environmental, the social, and the financial, it's often the financial elements that are really poorly addressed. And we see that with net zero initiatives. Right? Let's be really open about this. That's probably the weakest pillar that we have. So we need to really understand the financial concepts and frameworks and structures that sit behind these opportunities, and to also challenge ourselves on the business model associated with circularity, in particular outcome-based business models, which are very different from the conventional economic models. We also need to understand what market pools there are to create a business case, but I would suggest we do that without an over-reliance on regulation. If our circularity initiatives do not stand on their own 2 feet, just because we've got the three pillars of sustainability working in concert with each other and supporting each other, then I'm not sure that regulation, even a lot of regulation, will really make up for that deficit. So let's really understand how to deliver these initiatives with and without regulation. Although, of course, if we get the right incentives, that really can foster a circular economy and accelerate through investment. One thing that's absolutely key in this area of circularity is collaboration, and truly effective collaboration, and to really understand what works and how to have the transparency and the common objectives and the targeting that's really at the heart of effective collaboration. Of course, it goes without saying these days, visualization is such a powerful enabler of this transition that we really need to embrace the complexity of it, really understand what it means for these type of opportunities, and invest in the latest and best technologies. So I want to talk about that investment, and I work for a company that has thousands of customers across Europe. We have 3 million customer locations globally, so we pick up a huge amount of insights from our customer base. And I would like to just very briefly talk about their motivation to invest in water circularity, some of the obstacles in defining that investment case, as well as the obstacles in deploying successful initiatives as well. So when you look at the motivation to invest in water circularity, there are really three categories, and probably around 8 to 10% of the motivation is really around water cost saving. But I've already highlighted that the unit price of water can be very, very low, particularly in water scarce areas. So we look at the value in water, and of course that's really central to the iWAYS initiative. Look at the energy value, but of course the value of energy is only appropriate if you have a heat sink for that energy, and that's truly giving a lot of value, right? So we need to be really open about this. And of course, energy, nutrients, metals, organics, other recoverables, they can really boost the value of water. But nonetheless, we only see that cost saving or as a motivation 8 to 10% of the time. Even smaller fraction are what we call brand reputation impacts. These are normally B2C water users, where often water ends up in the bottle as a soft drink or as an alcoholic beverage. And of course, there's great sensitivity in those markets to how much water they're using, especially if they have operations in water scarce areas. But that's a relatively small part of the opportunity. The vast majority, I would argue, the 85% of the motivation to invest in water is really relating to water security. How do I have a long-term secure operation? How do I embrace water resilience? What does that really mean? How do I put metrics on resilience? How do I get the necessary insights at the local level to know if I have a resilient water supply, for example? And this is the big challenge that we face. And we need to quantify in this area of resilience and water security way above the quantification around cost and the value in water. This is a really big impedance. If we don't address it, we're not going to accelerate industrial circularity and transition anywhere near the speed in which we need to. Whoops. And I've already highlighted the low unit price, but what we need to understand is this resilience threshold that exists. And for that, we need supply data, we need demand data. At that local level, we need to use digital tools to really make the connection between supply and demand, to get the necessary insights here. And the reason this is so important is if you have poor resilience and you have a non-secure water supply which is not sustainable, then the whole essence of what you want to achieve at that location is really on risk mitigation. You have to adopt a very strict risk mitigation strategy. But water is such a powerful enabler for economic growth and development, and it's so vital to accelerating circularity. If we can be in this top category where we can see water as a catalyst for an economic growth, then great. So how do we tell if we are actually at a location where we need to focus on risk mitigation or actually economic growth enablement through water? And of course, you need a certain amount of insight at the local level to understand this. And this is what's missing across the UK. It's missing across Europe. We just don't know. We have some feel for resilience around infrastructure, but we often don't know whether the catchments, the local basins, the aquifers are truly resilient or not. We don't have that information in one place. And that's a very important aspect of having that understanding, is making sure that all the information that we understand around water is in one location, one database where we can make these connections, etc. It really explains a little bit around scarcity and some of the challenges associated with that. But what we also see in terms of operation, that as water becomes more scarce, there's a limit to what you can do within the fence in industry to actually manage those risks. The risks really move outside of the fence to the local area, and then you're very much dependent on other stakeholders at that location. And that's a real impediment to accelerating the water circularity, is that you're just not in control of the results. Particularly in water scarce areas, the outcome is completely dependent on the behaviour of other stakeholders at that location. So how do you then deal with a situation where you're responsible for delivering an outcome or return on investment when you have little control on that outcome, on that investment? And this is where truly effective collaboration matters. And a part of that is effective governance. And one of the best ways of achieving this type of collection of action is to have very, very clear local targets of what you're trying to achieve. Now, do I need to reduce water demand by 10%, 30%, 40%, 50, 60%? Well, the investment case, of course, is remarkably different between those different scenarios. So you have to be precise about what you're targeting. And we see a lot of paralysis across Europe in investment. And the number one element of that paralysis is what we aim for. What are we trying to do here? Is it 20% reduction or a 60% reduction to achieve a resilient water supply? So this targeting becomes very, very important. And then the next step is this coalescing around that target with all the stakeholders at that location, whether it be agricultural, municipalities, other industries. Unless there's something to aim for in a collective way, it's very difficult to drive big circularity initiatives. And I talk to you as one who's failed most miserably in this space. So I really take it seriously. I've been involved with so many projects over the last decade or so, and my performance rating is incredibly low when it comes to water. So we have to keep learning, reinventing, being this agile mindset, be determined to gain on outcomes. What are we truly trying to achieve? And it's really only in the last couple of years we're starting to see that kind of diligent approach actually pay off. So stick with it, and especially in terms of understanding the necessary governance at the local level and what that truly means in terms of success. Now, there are some fundamental challenges around investing in water. These are listed here: return on investment, often low because of pricing, long-term, etc. Poor governance. Water's so fragmented, even in relatively small geospatial locations and such like. We've already commented on the value of water and such like. So there are these fundamental challenges on investing or even accelerating in water circularity. But there are these big opportunities as well. But it depends on what lens we view water, and whether we truly view water as a growth enabler, one that we really need to underpin our future economic growth. And this becomes very important when you look at the growth opportunities for Europe, because we have in Brussels what's called the EU strategic autonomy. I'm not sure if you're familiar with it here, but it's basically saying that be independent and not be dependent on countries like Taiwan. We really need to build up our capabilities within Europe on data centers, on semiconductors and EV batteries and renewable hydrogen, etc. And all of those industries are very, very water intensive. They're very energy intensive as well. So unless we understand the role of water and the value that creates in heat transfer and efficiency and the economic elements of this, we are really going to undermine the opportunities. And of course, the easy thing to do is to deploy those new sites, factories, whatever, in the north and west of Europe, and not in the southern regions, of course, where water scarcity is typically more of a challenge. Right, so we really, again, need to understand these insights if we're going to make the right investment opportunities. But the key message here is that returns are achievable as long as you use the right economic frameworks and have the right business models, these outcome-based business models that I've highlighted. And then this is my last slide. You're probably glad to know we need to have absolute clarity about what the investment community needs. I've already highlighted the fact that it's often the financial pillar of sustainability that is weak when it comes to water circularity initiatives. How do we strengthen that? Well, we strengthen it by listening to the investment community and understanding what they need. Right? And we've done this recently with the European Investment Bank and insurance companies and such like, get absolute clarity on what investors need in terms of their return, the revenue models, the regulation, the blended finance, the way to de-risk initiatives, the transparency, the reporting that's so fundamental to these type of initiatives and such like. So in conclusion, water investment and the investment to accelerate circularity, water circularity, is available. There's a lot of interest in this area. We have to go beyond risk mitigation to really see the full value of water as an enabler within the economy, as a growth promoter, as something that underpins jobs and job security over the long term, to make sure that we explore all of these connections between circularity and competitiveness, because there are several that we really need to understand. Most importantly, to quantify them. So we're not just got a kind of feel as an area there, but we really get the data support it. And then to make sure that we have the investments required to scale at pace, right? To have that vision to scale very rapidly. And you can really only do that when the financial pillar is strong. So hopefully, sorry for being so fast, only 15 minutes or so, but hopefully that's made some sense. And I don't know if there's time for any questions or.
Thank you so much, Geoff. Any question for Geoff? But I have one question for you. In one of the slides, you said one of the reasons for this challenge, not to address, is that there is not adequate governance at the local level. How can we address this?
Yeah, very good question. So first point is to make a distinction between governance and governments. Governments play a very limited role in true effective governance of water across Europe. It needs to be stakeholder-led. If you have a big water-intensive operation at a certain location, it's in your interest to have effective governance at the location, and that means you have to look outside of your own operation and engage with the other stakeholders because it's a shared resource. Your risk profile, your long-term success, as I said earlier, is dependent on the behaviour of others. So how do you manage that? Well, you at least reach out to them and start to build connections there. But very, very importantly, what we're seeing as working now in this area of governance is to have these targets that I mentioned. The moment you collect water supply data, demand data, makes sense between supply and demand in terms of understanding environmental flows, sustainable water use. You can use neural networks, fantastic tool to enable this and bring it to life. The moment you know what you need to do to achieve resilience at that location, then you have the beginnings of governance, because suddenly you have an action plan around a target that you can coalesce around. You have insights that you can take to other stakeholders at that location and say, this is what we need to do together within this catchment or in relation to this aquifer. And so it has to be, governance has to be very, very practical, right? And invariably it's data-led and target-led. But governments, their track record is very poor at driving change at this level. Even really well-run based authorities struggle to truly drive effective governance.
Thank you for the comprehensive presentation. In your opinion, if we want to invest, where is number one investment should go in the direction of water?
Yeah, so I highlighted earlier the water energy productivity nexus. We need to be all over that because, as I mentioned, that's where water creates its most economic value at the heart of production. So we're seeing a lot of interest in understanding those dynamics and using digital applications. So the water energy nexus by itself is a really fertile ground for investing, because of course energy prices are high. There's a lot of concern around emissions, but you need to tell you that and such like. Energy boosts the value of water so considerably, but that's not always easy. As I mentioned, you have to have a heat sink. for recovered energy. And so unless you're integrating that into a big industrial process or district heating in Eastern Europe, whatever it is, the economics again don't stack up. So water energy nexus is really important. And then there's relentless pursuit of productivity and the connections that productivity have with water and energy, because that's a super fertile ground. But you have to have the right type of insights, deploy the right technologies and such like. Thank you.
Thank you very much, Geoff. Now is the time for having technical coordinator of the projects to take the floor. So I'm glad to call Professor John Sam for having an insight on the iWAYS project. The floor is yours. Thanks.
Right, here we are. Final conference. Who believes? I mean, we started 5 years ago, nearly. It was December, just before the pandemic hit us. December 2020. I think the pandemic started between lockdowns, etc. Never knowing, are we going to have our systems up and running one day or just virtual? It was really unclear. Now, 5 years, we are here. Now, what I'm planning to present to you is really the idea that created iWAYS and how iWAYS basically came up to become a viable project and a solution. So in the coming slide, we will have, you have here two amazing illustrations by our partners, ESCI. One of them on the left, I don't know if you can, you can see it. The one that says ETEKINA, that is a project that started 2015, 2016, and 17. I'm starting to forget the years now. In 2017, we started ETEKINA. It was a project on the utilization of heat pipe technology in 3 sectors: steel, aluminium, and ceramics. And the idea was to utilize lots of unused or irrecoverable waste heat from very challenging streams. For example, in the steel industry, we had exhaust streams that fluctuates in flow rates in the factor of 2. Temperatures fluctuate from 200 to 600, and it's really something you cannot put any heat exchanger to recover the energy from. It was just impossible. In the aluminium industry, the requirements was for very high temperature heated gas from the waste heat recovery, which is a challenge. And in the ceramic industry, we had the issue of long distance heat transportation and fouling. So in ETEKINA, we managed that. We have a showcase for us in a leading ceramic company in Europe called Atlas Concord, and one of their factories, Mirage, where we installed basically at the beginning of everything in Dream Project, we saw the small unit, but then we moved on later on to the company itself, and we installed 700 kilowatts unit that recovered heat from low temperature, relative low temperature exhaust stream, transporting the heat 200 meters using pressurized water. So ETEKINA came with its own challenges, which we managed to overcome. What we couldn't do in ETEKINA was, whatever we did, we had to keep the exhaust outlet temperature above 150. The reason for that is we didn't want the acids to condense in the stacks, because if they do condense in the stacks, they will cause corrosion. The stacks will be compromised from a stability point of view. Having said that, during the ETEKINA days, we actually managed to cool down the Atlas Concord unit to below the dew point, and we saw the water flowing from the units. It wasn't a very nice thing to do, but we managed to do it for a few minutes. We took a video, and the idea behind iWAYS was born. Why don't we do something to actually condense that water? We know we have to condense acids, sulfuric acid, nitric acids. In other scenarios, hydrofluoric acids, lots of nasty corrosive materials. So what is the challenge? Materials. We need to find resilient materials that can actually withstand the corrosion. What is the motivation? Water recovery. In ETEKINA, the focus was mainly on waste heat recovery. It drove the whole project, and we delivered it successfully. In iWAYS, in addition to maximizing the waste heat recovery by condensing, the challenge of recycling water is the main one. That's why we have Water Europe, for example, today organizing this amazing event, because water was the main target. The idea was designing the heat pipe condensing economizer. You can see it on the left there. It will recover the heat and cool the exhaust below the dew point of the water. In the process, we condense acids. We can actually separate the condensation stages, so we can treat each flow independently. In the project, we have Siemens, we have ECRA, and they are basically with us partners to recycle the water, treat it, and make it reusable in the factory itself. And so this is really the main difference between the two. ETEKINA being the leading project, the parent project, iWAYS being the child project that is now grown up. We delivered now 3 mega units. The last one was 2 weeks ago in Atlas Concord, successfully, if I may say so. We managed to successfully install the units, and you can see them. The ETEKINA unit on the right, the iWAYS unit on the left, both in Atlas Concord group companies. The one on the right is 700 kilowatts unit designed for capacity up to 1.3 megawatts if the exhaust conditions allow it. The one on the left is 1.7 up to 1.7 megawatts. It can go up to 2 megawatts if the conditions allow it. The one on the left, you can see the hose at the bottom there, the tube coming out, and that is where the condenser basically flows out. Now, please have a look at this video. I'm so proud of it. When I saw that video, I thought, right, well, iWAYS is now proven. We've seen that before in ALUFLOR, which is one of the partner companies we have, but we really didn't see the condensate flowing. We knew the condensate was flowing from the sensors, but we didn't actually see it. We have here exhaust running at part load, 50% according to the company, 50% of the flow, and the temperature was lower than the design. We were recovering 0.5 ton of water an hour. And this is the unit operational. I think from R&D point of view, it's maybe one of the largest units we installed. And yeah, successfully. Now, what does this tell us? We started with one thing, ETEKINA, recovered the maximum we could recover what we knew. iWAYS pushed away further. Now we are recovering. In this scenario, we recovered 75% of the available sensible energy. You might say, well, that's a bit of cheat. No, it's not. 75% of the available energy that you can recover from sensible means, it is being recovered and recycled to the company. That's one. 0.5 ton of water at part load being recovered. It will be treated, reused in the factory. Talking about Italy, Spain, south of Europe, water is important. This will save the company a lot on water, on energy, etc. And yeah, as a team, iWAYS, I'm sure you will all share with me, everyone in the project played their role. We all made it work. And I'm so pleased and honored to be here talking about this with everyone. And yes, thank you to the whole iWAYS team. This is really, yeah, we always take this photo. So when you look at our LinkedIn photos for all the projects, always thumbs up. Yes, good. So enjoy the rest of the event. And thank you, Andrea, for your invitation for me to talk.
Sure. Even though it's still you now.
I'm still here. I'm not going anywhere.
So we have a number of movies showcasing the technologies, cutting-edge technology of the iWAYS.
I can mention something about this. So later on, there will be a session. The session will all be about videos for the demos. I will take you through them because we are so proud of them. I mean, really, we make things. But if you have any questions in the meantime, I don't know, Andrea, have time for questions or?
Well, the question is, once again, it's a consideration. It is possible.
Yeah, if you like.
I mean, it's possible to recover water and energy.
We have. In iWAYS now, we recovered, I mean, the unit was running at part load, Andrea, correct me if I'm wrong. It was running at part load. The exhaust flow rate was nearly half of what the design conditions were in the actual proposal. The temperature was 92. The design conditions were 105. So lower temperature, half load. We recovered from that unit between, if I remember the numbers correctly, 450 to 550 kilowatts at part load. Now I ran the numbers. If we had the design conditions up there, we would have achieved 1.3 megawatts. So we recovered the heat. 0.5 ton of water at part load. So if the unit was running at full capacity, we will meet the targets that we promised. And that water will be recycled through the Siemens system, which is up and running. The sewage system will recover the water, treat it, and recycle it to the plant so it can be used. So we managed to recover water, we managed to recover energy. We did the same in ALUFLOR. In ALUFLOR, it's much more a complex situation, and you will see later the videos. In ALUFLOR, they have hydrofluoric acid, they have fluoride, they have lots of challenging chemicals. With clever, innovative approach for selecting materials, thermal design, we managed to do it. We are now, ALUFLOR are now considering a much bigger unit beyond iWAYS. So they don't have any vapor coming out of the stack because that is huge value to them. Now, incidentally, you will see later how we do it as an R&D project. We started with a demo unit in LAI. That demo unit, we managed to explore lots of ideas. And from those ideas, validating the theories, we actually managed to build the 3 other units afterwards.
Thank you so much. So I think that we can go ahead with the movies, and if there is any question.
Oh, so we do the movies now?
Yeah, the movies are now.
Technologies are now.
Sorry?
Now we have.
Yes, I mean, yes, yeah.
So there is a break for me anyway, so it's good.
Oh, okay. Yes. So, we start with one of our speakers online, Geoff Romanos from NTUA, National Tech University of Athens.
Yes, good afternoon, and thank you for
Good afternoon. You're welcome.
invitation.
And I mean, the title of your presentation is Development of a Novel Photocatalytic Reactor. So the floor is yours. Thank you so much for joining us today.
Thank you very much. Okay, so I will talk about the procedure for the development of a novel photocatalytic reactor implemented during the iWAYS project. I'm George Romanos, and I'm a research director at the National Technical University of Athens. So the main target we had was to remove any organic contaminant found in the wastewater of steel-making industry. Actually, the end user is Tubacex in Spain, and the wastewater comes from the degreasing baths they use in order to clean the products, the produced steel pipes and tubes. In fact, the technology is applied after a pretreatment stage, which involves a dissolved air flotation process and coupled with a membrane distillation process. So the photocatalytic process comes as a post-treatment process in order to oxidatively degrade any organic contaminant, especially some surfactants that are used in the degreasing baths. So since the target was to apply this technology in the industry with real water, we had to also address some aspects and make the technology attractive for an industrial site. So the additional target was to develop a reactor with a small footprint in order to be retrofit in the space available in the steel industry plant. And this reactor should have a water treatment capacity of 10 liters per minute. Another challenge was to achieve great efficiency, meaning that we had to remove all the surfactants that are contained in the water. That could be up to 300 parts per million with one-pass procedure in order to avoid recycling that of course, reduces the water treatment capacity per day. And the third challenge is to shift from a reactor made of stainless steel to a lighter construction, and also to be able to have access to the active elements, the photocatalytically active elements of the reactor, in order to make easier their replacement in case they are degraded after several months of operation. So the development phase included the conceptual design, which was targeting the dimensioning of the reactor and the active elements. Then we passed to the design and construction of the active elements, applying some innovative approaches like mask stereolithography 3D printing technology coupled with salt gel deep coating procedures. Then the next phase was the detailed design of the entire system and its construction, the factory testing, of course, and currently we are at the phase of the commissioning and operation at the Tubacex site in Spain. So you can see here some figures and photos from the several development phases. On the left side, the conceptual design. Here our target was to design in detail the hydraulic parts of the reactor, especially these active windows you see here. That host the active photocatalytic elements. You can see here that we have used the acrylic material in order to go to a lightweight construction and be transparent for the UV light to penetrate and irradiate the active surfaces enclosed in these windows. So all the designs were and the construction was based on CNC machining. The most innovative part of this technology are these lattices, which are 3D printed. And as you can see here in this photo from the optical microscope, they have a very rough surface. This means that they have a very high aspect ratio, so this leads to the miniaturization of the reactor, meaning that we can have a very high active surface in a very small reactor volume. So the procedure was first to print these lattices, these active lattices, and then deposit on their surface the active photocatalytic material. Actually, we have invented a triple coating process. First, we deposit some silica in order to protect also the polymeric substrate from the UV radiation. And then we proceed with the deposition of two layers of active photocatalytic material, which is in our case was the CUSA titanium P25. And you can see that through this procedure we have produced 60 modified lattices to be incorporated in the reactor. Each lattice has a dimension of 15 to 15 centimeters. So the next phase was the detailed design and construction of the system based on the PNID diagram, and we have defined all the components, either electronic or electrohydraulic, that should be incorporated into the reactor. And you can see here on the right the final view. This is the electric box with PLC and control screen here. The acrylic windows that host inside the active photocatalytic elements. You can see here that there is mechanism that, like a rack, you can take out from the reactor box these elements and replace them very easily. So now we are in the phase, as I told you, to send the system to Tubasex, do the commissioning and validate it with real industrial water. And thank you very much for your attention. If you have any question, I will be happy to answer.
Many thanks, George. I don't know if there is any question from the audience. Otherwise, we go to the next speaker, which is Matteo Venturelli from the University of Modena and Reggio Emilia, and he will speak about the role of numerical simulation into energy-intensive industries from DREAM to the iWAYS project. Thank you, Matteo. The floor is yours.
Thank you very much, Andrea. Good afternoon, everyone. We have already heard in the previous presentation from Professor Jouhara about three different European projects, DREAM, ETEKINA, and iWAYS. And today I want to show you how the numerical simulation has been used in these projects in order to predict the performance and the behavior of different energy systems. In the DREAM project, one of the partner was Atlas Concord, and it is a pleasure that this very important ceramic company is here with us at this conference. And we have worked with them in order to optimize the energy efficiency of the ceramic kiln. I don't know if you are familiar with this kind of system, but they are systems that are more or less 100 meter long, and they are quite energy intensive processes. We can have a look at, what is the pointer here, at the energy consumption. It's a rough estimation. And we have used a lumped and distributed parameter model in order to develop the, we can say, digital twin of the real furnace. So starting from the real geometry, we have included all the material that compose this kind of system. We have considered the actual operating condition, and we have tried also to simulate the complete physics and the heat transfer mechanism that takes place in the kiln. And okay, so in here we can have a look at the numerical model, so at the virtual kiln, how it has been implemented in the simulation environment that was software from Siemens, Hemsim. And so we have reproduced all the different sections that compose the real machine. So the preheating modules, the firing modules, and the cooling section. And here it is zoom on one of the modules, so we can identify all the main components, so the lower chamber, the rollers on which the tiles travels along the kiln, and the tiles, of course, and also the upper chamber. And the first step was to validate our numerical model. So we have compared the numerical results with the experimental one. So we have placed a data pack system into the kiln that was traveling with the tiles in order to measure the temperature of the air and of the tiles. And as you can see, there is a really good agreement between the calculation and the measurement. And so once that the system has been validated, we have worked with HPCE, which was another partner of this consortium, in order to optimize and study a cooling profile that was minimizing the residual stresses in the tiles. Because, as you know, the residual stresses of the tiles influences the mechanical properties of the tiles itself, and so the idea was to provide a new cooling profile that was minimizing these stresses. And another study has been done in order to optimize the energy consumption during the the standby phase of the kiln, because when the system is waiting for other tiles to be fired, we have studied some operating condition that minimize the energy consumption of the kiln itself. And we have analyzed different scenarios in terms of temperature set points of the burners, or pressure drops, set points of the fans, and so on. And we were able to reduce the energy consumption of almost the 30% of the kiln during the standby phase. The second project was ETEKINA. We have already heard about this project. It's the father of the iWAYS project, in which the heat pipe condensing economizer has been applied in different industrial sector. Again, the ceramic one. And we focused our attention on the heat recovery of the ceramic from the ceramic process, in which the idea was to recover the heat from the wasted energy that is contained in the exhaust stream of the ceramic furnace. So using the heat pipe, this thermal power that is recovered is transferred to this heat transfer fluid, and the heat is reused into the spray dryer in order to preheat the combustion air of this system. But there were two main issues to be considered. The one is the fouling that could occur in the evaporator section of the heat pipe condensing economizer, because, as you know, the exhaust streams contains particular matter, and so there was the risk to clog up the system. And the second risk, as we heard before, was the acid condensation that could occur at the outlet of the pipe condensing economizer, because we are cooling down the exhaust, and so if we cool the exhaust at a temperature lower than the acid dew point, then of course there is acid condensation. And also in this case, using I would say a combined approach, we have developed a 0D1D model with the same software in order to design a control strategy that was able to keep under control the temperature of the exhaust at the outlet of the pipe condensing economizer. And after that, we have used the CFD analysis, in this case a Lagrangian approach, in order to simulate the fouling phenomenon, and so how the particulate matter sticks on the heat pipes and how it influences the performance of the heat recovery unit. And now I'm going fast because not so much time, but here you can have a look at the numerical model, and this is the control strategy that we have studied. And having a look at the results, so here we can see the fluctuating experimental temperature and flow rate that we have used as boundary condition for our model. And according to our to the strategy that has been designed, we were able to keep the temperature at the outlet of the temperature of the exhaust at the outlet of the pipe at a value higher than the acid dew point. And finally, we are coming to the iWAYS project. Here I want to show you an example that is being applied to a steel demo case, which is a Spanish company. And in this case, a radiative pipe condensing economizer has been used to recover the heat generated by the hot rod cooling. So you have to imagine in the furnace that these metal rods are traveling in the kiln, and cold water is injected in order to cool down this material. And the idea was to recover the radiative heat with the heat pipe condensing economizer, but it was difficult to estimate the amount of heat that we could recover. And so in this case, we have developed a really simple numerical model, and we run a performance analysis simulating different heat recovery, starting from 20 kilowatt up to 80 kilowatt, and in order to see how the system behaves. And for example, here we can have a look at the results of the 60 kilowatt simulation. And so we can see, for example, the temperature of at the inlet and outlet of the heat pipe and at the heat sink. So that's all from my side. Thank you very much.
Thank you, Matteo. Thank you so much. Any question? So we are a bit behind the schedule, so we go to the last speaker of this session, and I'd like to invite Edgar from EURECAT, who is joining us online, and paving the way to Industry 4.0, smart technologies for a sustainable industrial future. The floor is yours. Thank you.
Okay. Could you see my screen? Sorry, could you see my screen?
Can you give me? Yes, we can.
Okay, thanks. Good afternoon. I'm Edgar Rubion from EURECAT, where I lead the group of artificial intelligence solutions in the field of water and climate change. Today, I will share how our work in the iWAYS project supports sustainable industrial transformation through smart digitalization, basically showing how we move from fragmented industrial data to actionable through worst insights for a more efficient and greener industry. To reach climate goals, industries must not only decarbonize, they must digitalize. We call this the twin transition, green and digital transformation working together. On one side, industries face pressure to meet environmental and social standards. On the other hand, digital tools offer new capabilities, but only when supported by reliable data. No, it's important to the quality of the data to take advantage of these digital tools. Industry 4.0 gives a powerful model, one built around data, and in iWAYS, this data-centric approach helps recover water and heat in smarter and more efficient ways. But many digital initiatives fail before they scale. Why? Because of data silos, lack of interoperability, poor of missing real-time data, and legacy systems that resist to perform the integration and difficult the integration of the information in the digital system. And even when artificial intelligence is applied, there's often a lack of trust in these inputs, in this output, sorry. That's the challenge we address in iWAYS, building an integrated and trustworthy digital backbone to support the advance towards the Industry 4.0. This is the foundation of our work. There is no smart factory without smart data. Real-time data enables real-time decisions. Good data ensures accurate decisions and support the artificial intelligence not to be applied in the industry. And for artificial intelligence to work with the industry, it's very important to have a volume, a veracity, and a velocity in the data streams. In iWAYS, Eureka focused on building an infrastructure that not only connects and collects data, but make it usable and trustworthy across all layers of industrial decision making. What we have developed in iWAYS is not just a monitoring solution, it's a complete digital pipeline that transforms raw industrial data into reliable and actionable insights. These pipelines begins with real-time data acquisition from existing third-party systems, basically using Industry 4.0 standards like MQTT to ensure the efficient and scalable communication. Once collected, the data undergoes robust pre-processing, cleaning, validating, and structuring this information to make it accurate, consistent, and usable across the platform. A key achievement is the homogenization of data across the three very different industrial environments. We have implemented the same architecture in the chemical sector at ALUFLOR, the ceramic sector at Concord, and the metallurgical sector at Tubacex. Despite their difference in processes, scale, and systems, we apply the same digital backbone across all the three cases. Basically, this digital backbone has a part to perform the homogenization and transformation of the information and to connect to the different use cases. That is this part. After we have an MQTT broker that is responsible to orchestrate all the information in the platform, we have a pre-processing model to ensure the quality and the transformation of the information. We have a persistent model to store the information to be processed and exploited in the future. We have a visualization layer and an interoperable layer to communicate with third-party application. For example, the decision support system. In short, we have shown that a single modular and digital architecture can be adapted to serve diverse industrial contexts, laying the groundwork for widespread scalable adaptation of smart, sustainable, and manufacturing practices. The iWAYS pipeline is essential because it turns raw, scattered industrial data into real-time, reliable decisions. This slide shows how digitalization unlocks the full value of industrial data. On the left, we see the data preprocessing, where raw signals are cleaned, structured, and improved using smart algorithms. This step ensures that we are working with high quality and usable data. In the upper right of the picture, the system developed by Brunel University recommends optimal water reuse based on both availability and quality, helping industries recover resources more efficiently. And on the lower right part, we see time series dashboard used for remote monitoring, allowing the operators to track energy performance and the general performance of the solution in a remote way. Together, these layers form the digital backbone of iWAYS, moving from raw data to real-time impactful decisions. As we look ahead, the path is clear. This approach must now be scaled across sectors, but scaling is not just about technology, it's about building trust. That means developing transparent, explainable artificial intelligence, promoting open and interoperable systems, and ensuring a robust infrastructure that can support real-time data-driven decisions at every level. At EURECAD, we are fully committed to advancing these principles so that digitalization not only accelerates innovation, but also delivers a greener, more resilient, and future-ready industry. And thank you for your time. And I don't know if you have some questions related to the presentation.
Thank you, Edgar. Any question from the audience? The last presentation of this first part of the session on the final conference, the iWAYS. Here's a question.
Hi, that was really good. I love the iWAYS program. I think it's marvelous. So there's a frequent mention of software from Siemens. Is that available to people outside iWAYS?
Basically, all the software that we are using is open source software, and we are using the same infrastructure for Connect in all the use cases.
Thank you so much. So let's have a very short coffee break. If we can do it in 50 minutes, I will be really very much grateful. Thank you.
Okay, I don't know if everyone is back. So can you start with the beginning? Just wait until I see.
Yes.
Okay. So again, thank you, Andrea, for organizing the session. What we will see now is really the project. What have we achieved? As you know, in Horizon projects, it's all about what have you delivered, not what have you written, even though you have to write. But if you don't deliver, then the project is really not successful. So I will take you through the story here. If we can just restart the video, please. I will start with our very first activity in the iWAY project, which is the LAI setup. What you see here is the lab that we built in the Lithuanian Energy Institute, where we condition the exhaust, so we can create the exhaust composition we like. We can control the moisture content. We can control everything. So we can actually put acidic vapors in, so we can create a composition that simulates what's happening in any factory, really. There is no limit there, except maybe a couple of acids that we could introduce for safety reasons. The exhaust then, the preconditioned exhaust, will go through the first prototype of the condenser economizer. You see it there, which is the unit that is insulated. Exhaust flows through. At the top, we have water cooling. Everything is measured. The idea here was to do it right at the beginning of the project. If something is to fail, would like to know about that straight away. So we tested various materials. We basically tried various flow rates. We did the condensation. We checked how the condensate is being collected, how to basically collect. You can see 3 points of collection. Is the theory about separating the acid from the water condensation through the groups that we have inside works? It did. We actually collected the condensate. You will see later the condensate flows to the second level, which is here. So the condensate flows down. We collect the condensate in containers, and we basically measured the various elements in the condensate. So we have three. You can see 3 containers. We take samples. We test to validate that what we have designed. In our design, we were expecting certain sensible energy to be recovered, certain amount of water to be recovered, condensing all the acids, condensing some of the water, and we validated that here. You can see some of the acidic. This one actually is stage 1. It's where mainly the acid condensed. And then here we have a solution between nitric acid and water. The last one is where the water condensed. So this large-scale lab is really the dream for any researcher. For me, created the system using my numbers. It's always, I had no doubt. Having said that, you always have at the back of your mind, what if? So this here actually helped us to validate. In addition to the heat side and the heat pipe side, what you see in front of you is what we collected after the experiments were concluded. So we collected all the samples in large containers, and then our partner Siemens, they brought the lab scale water treatment system. They brought it on site, and we basically treated the water to show that our water treatment system can actually do the job and can treat the water to the level where it can be recycled back to the factory and can be reused. If you look at iWAYS, it's all about water recovery in addition to the energy. So this for us was the main validation point. So in LAI, we validated the heat pipe condenser economizer. This is the actual name, HPCE, heat pipe condenser economizer, validated. Grouping the condensates in groups, validated. Thermal recovery, validated. Treating water using the system that we have developed by our partner Siemens, validated. In addition to this, the control strategy, etc., had access to the lab so they can actually do various tests. And for us, this was the pinnacle at the beginning of the project. So within the first 18 months, we managed to get things up and running over there. And that was really the most important thing for us because we were just entering unknowns when it comes to condenser economizers and showing that you can condense while not corroding and not destroying your metals in the process. You can see basically this video was created for one of the review meetings, just describing everything you see in this video was created in the iWAYS project. Every single piece, every single instrument, every single device. So that gives you an idea, even on the lab scale, the amount of work that has been done within a very short period of time. So yes, this is the LAI setup. Even though we're calling it lab scale, it's really more of a small demo. When we say small demo, the unit that we installed there is capable of heat recovery up to 150 kilowatts, if the conditions allow it. The water recovery can be controlled based on the conditions that we introduce. So this is really the LAI unit. This unit is there for the next project. So the beautiful thing about European collaborations is we created something here. Hopefully this will be used in the next project to take the idea further. So the team still working on that, and we're hoping that we can actually push it forward. So this is for the LAI unit, the very first unit that we validated in iWAYS. The second unit is in ALUFLOR. Now, this unit was done, and we worked with the partners to do professional recordings. So hopefully that will be self-explanatory. I will leave it to the speakers to show you basically what's happening, and I will do the comments after about how the system performs. But before you see the video, this was deemed impossible at the beginning. We made it possible. So we talk about hydrofluoric acid, fluoride, very corrosive elements. So hopefully, you will see the impact of the iWAYS from this demo. Okay.
Aluminium fluoride is a chemical vital for various industries, including the production of aluminium. In making pure aluminium, it is a crucial flux material and reduces the energy required. Processing these chemicals requires huge amounts of energy and fresh water. The exhaust stream from the process still contains large amounts of these resources. Aluminium fluoride producer ALUFLOR in Helsingborg, Sweden, wants to reuse these resources instead of sending them up the chimney stack. But the exhaust is corrosive, and recycling the energy, water and material involved is a real challenge. A new system developed within the EU-funded project iWAYS now overcomes this challenge, creating value from the exhaust streams of chemical production and other industries. ALUFLOR is testing one of these systems. Professor Hussam Jouhara from Brunel University of London is the inventor.
Condensing economizer has been developed with factories with no chimneys in mind. It is recovering the heat that has been otherwise wasted. It's condensing the water and the acids or whatever inside that stream in the liquid form. So what we are left with is really CO2, oxygen, nitrogen, and maybe some other gases. With the heat pipe condensing economizer, you are actually controlling the capture of all these contaminants in the liquid form. So it gives the industry much more control on the emission side. And I believe the chemical industry in particular will find very good use of the condensing economizer because it will add, in addition to the energy efficiency, water recycling, materials recovery.
But how exactly does the technology work? The heat pipe condensing economizer, HPCE for short, is based on heat pipes, which are sealed and filled with a working fluid. This transfers heat quickly and passively from the hot bottom section to the cooler top part. In an HPCE, many of such heat pipes are assembled in a specific pattern. A hot exhaust stream passes through, transferring its heat to the upper part where cool water absorbs the heat. During this process, condensate containing fluoride forms and runs down the pipes. The condensate is collected with other wastewater from the HPCE system and sent to a water treatment plant. The treated water can then be reused. After this process, the exhaust is purified and cooled further in the condensing economizer before it finally leaves the facility through the stack.
I'm wet, but I'm good.
The water that absorbed heat from the exhaust can reach up to 70 degrees Celsius. This is used to clean equipment, like the reactor, for example.
We looked at very cost-effective design for it and demonstrated that for such harsh environment, we can actually do a modular, flexible design for the condensing economizer.
The researchers expect the HPCE to drastically cut ALUFLOR's water and energy usage, achieving a substantial reduction in its annual energy consumption. Dan Tourisson is the technical director at ALUFLOR.
We strive all the time to reduce the energy consumption, the material consumptions, and reduce the emissions, even if we are well below the permit we have. We continue to strive lower and lower. We think that iWAYS will help us a lot with this.
Integrating the new technology into the existing infrastructure required careful planning and coordination. But once operational, the benefits were evident almost immediately.
We have been running it for a couple of months now, and it has worked very well. So we have got the transformation of the energy from the gas to the water, and we have also seen reduction of the emissions.
This chemical production site in Sweden is only one of 3 case studies testing the new technology. A second HPCE was installed in a ceramic production site in Italy, and a third one in a steel production site in Spain.
You can apply the same thing to any other industry, but you can see where the chemical industry in particular, because they are heavily regulated, they will benefit the most, I believe.
Right. Well, you can see the power you have if you have a good media company. Looking here at Elmar and ESCI, I do believe they actually managed to convey what we have in our minds clearly in a language that maybe as engineers we can't always, we can't always simplify things. So Elmar and your team, thank you very much. Water Europe, thank you very much. I know you guys have been really working hard with us to understand some of the things we say. What the hell are you guys talking about? No one knows. So thank you. You managed to convey our message very clearly. I really appreciate what you've been doing in the project, and it was part of the success. What you see in this demo is really the very first real-life demo case for the iWAYS project. We have been running this unit now for nearly a year. I think it was installed August last year. We had the saving figures in euros, really good ones. I'm not sure I can repeat them, but the company is making money out of it, which is normal. The energy that was recovered, or is being recovered as we speak, this energy was just being dissipated to the atmosphere. Not only we are recovering it, the water that they are recovering is also being treated and reused in the plant. A huge success for the project. Looking at a chemical company like ALUFLOR, getting through the door is not something you can actually achieve easily. You have to convince them that you know what you're doing. And being, academics, researchers, you have to actually show the industry that, you understand their language. So the very first thing we did with ALUFLOR was to show the theory, to show the validation, to actually have them involved in what we were doing in LEI. And that was so helpful because then they actually saw the scale of things and how the compatibility was there, the materials selected, they did the job. So that's how we worked together with them and we managed to install a fantastic looking unit. The unit actually sits at the top, above the roof. As you walk through the industrial site, you can actually see it until now, which is fantastic. The good news also is the company is now in discussion about a bigger unit. So that is even bigger success for the project. I did mention something crucial in the video, which is what the condensing economizer does. It not only condenses the acid, it also condenses some of the water. Can you imagine now having an active, a very good carbon capture system sitting at the back of this unit? The carbon capture system will have clean exhaust that consists of CO2, nitrogen, oxygen, maybe a small amount of water. A dream exhaust stream that you deal with, capturing the CO2. What you end up with is really a gas that you can inhale with no issues. That is our dream for what I mentioned at the beginning, factories without chimneys. So that was our first industrial demo, running until now successfully for a year. The next one, I believe, is the steel in NTUA 6.
Steel, the backbone of industry. It's everywhere. Hairpins, helicopters, high-rises, you name it. But steel's production consumes a lot of energy and thus money, more and more money. Since 2022, energy prices in Europe have risen by up to 40%.
The bigger challenge of the steel industry in Europe is the cost to remain competitive. We have a challenge with the price of energy, of course. We are huge consumers.
Moreover, the European steel industry accounts for about 5% of the EU's total CO2 emissions. Innovation is overdue.
We need steel for everything we do. And we can make steel manufacturing sustainable. We can make it low emissions by ensuring that any bit of energy is used in a very efficient way and no energy is being wasted. No water is being wasted. This is our hope, and by achieving this, we'll have a very sustainable steel manufacturing process.
Hussam Jouhara is the technical lead of the EU project iWAYS, in which he devised the radiative heat pipe condensing economiser, HPCE for short. His innovative heat exchange technology is now being integrated into the furnace line at the Spanish steel mill Tubacex.
This system recovers the heat from the hot steel that goes through the ovens. It also condenses the vapor that is evaporated when we cool those surfaces. And when it condenses, it absorbs that heat also, and it cools the air that is departing those ovens. The heat that is absorbed is then recycled back to the plant and is used in the degreasing tanks that they have in the factory. So we are basically absorbing heat that was otherwise wasted, putting the heat back in the process, saving fuel that was used to do that heating.
But installing the new system in a 24-hour live industrial environment was no small feat.
The main challenge was to install it without disturbing production. It's very difficult to install HPCE on top of the furnace without hindering production and maintenance teams to access the machine.
The first test run of the HPCE was successful, proving it to be a promising technology.
With the help of the HPCE, we will be able to reduce gas consumption and CO2 emissions.
Alongside recovering waste heat, the iWAYS partners also targeted industrial water. The steel industry uses large volumes of water to clean and cool equipment.
The water here is quite dirty. I mean, they use it in order to degrease the stainless steel products. so it contains many organic compounds, and there is the need to treat it in order to reuse it. So filtration is one of the best approaches in our days.
To permit the polluted water to be reused, the experts installed a pre-treatment stage, which removes about 80% of the particles. 2 steps of filtration follow. The first is membrane distillation.
It is actually a hydrophobic membrane that allows only water vapor to pass through. So at this stage, the effect is very high, and we can remove about 99% of the contaminants, either organic or inorganic.
Some volatile contaminants can still pass through. Therefore, the final stage of the process is nanofiltration. Here, high surface area materials, coated with a special catalyst, break down the remaining contaminants under UV radiation.
The benefits are that you can recover about 95% of the water to be reused in the industry.
The results so far are significant, both for the environment and for the factory.
I'm hoping iWAYS will pave the way to stop all of that waste, collect it, bring it back to the process, recycling the water, recycling the heat, achieve over 90% of recycling all of those quantities back to the process.
Reducing waste and emissions could be key to keeping steel production in Europe and elsewhere viable and sustainable.
Again, thank you, Elmar, and your team. Amazing, amazing production. What you see here is really something that hasn't been touched on before. You have all these red hot surfaces just losing heat to the environment. They're just simply radiating the heat. The heat is being absorbed by air or surrounding surfaces. There's no economical way of capturing that heat and recycling it. So what we have done here, having a flat heat pipe design, not only it can absorb the radiation. You see this red color, that's radiation hitting the surfaces, absorbing that radiation, converting that heat into heat that the heat pipe can then transfer to the water that is cooling it, and then that is used in cleaning and heating the chemical tank that they use to clean and degrease the tubes. From the waste heat source all the way to the heat sink that is in the factory. So we have full cycle of the waste heat back into the system, in the process saving the energy that was used to heat that water. It's a radiative waste heat recovery system, didn't exist before, and it's operational. The next step for us now is to do the formal commissioning of this unit. We did the initial test, fantastic, few adjustments, and then we'll do the final commissioning next month, hopefully. So this is really for us, it's a small scale when compared to the ALUFLOR one. Having said that, the largest unit is to come. So the next demo is our demo in our partner's facility, Atlas Concord. You saw the photo of it before when I was talking about the journey from ETEKINA to iWAYS, but I will take you through the system now, just to explain what we have done there, because for us it is really big. The height of this unit is very tall. You can actually see it from looking at the people next to it. This is a system I talked about before. Exhaust flows through. At the top, we have water. The water is cooling the heat pipes. We are condensing the water, collecting the water. At the bottom, you saw in the video earlier on, that's the water being collected. And this water is acidic because it has acids in it and also some particles. We take this water from here. In our commissioning test, as I said, 0.5 ton an hour for part load. We take this water to our partner's facility, Siemens, in Atlas Concord. They have the full installation. They treat that water and they bring it back to the process. The heat that we are absorbing in this heat exchanger, it goes to the process. I believe the spray dryer is one of the applications for the heat. So we have direct use of that heat. And whatever heat you use from this system, you have an equivalent saving in natural gas that was otherwise used to create this heat. So it's nearly 4 meters high, very large system, and it's still operational. To my knowledge, it is operational with no issues, running in a dynamic way based on the way the system operates in the facility. We haven't yet done the professional video for this unit, but you can imagine how it will look like from the other two. The commissioning was done early in July. I think it was the 12th, maybe the 11th and 12th, so not long ago. And I believe ESCI is in the process of creating the formal video, but we just wanted to share this with the conference here. For us, this is the concluding demo, and now we have delivered the iWAYS project from technology point of view, HPCE and water recovery, and also our partners in the project working on the control strategy, on the instrumentations and cloud, etc. We are actually getting very close to the end of the project, which is in November, after a very challenging few years with the pandemic being in the middle. So with that in mind, I believe all the videos now seen, you've seen the demo cases. If you have any questions about any of the demos, please let me know, and then we can expand further.
Thank you, sir. Thank you very much. We have been going through demos, which proved to be successful. Now we need to see how we can scale up. So, full scale. Yeah, but I mean, good. Let's go to market now. Let's go to market and exploit the iWAYS results.
Are you accepting questions?
Yeah, I mean, the chair.
Yeah, we accept questions.
You have probably two questions. I speak loud enough. Yeah.
It's for the online. It's for the online. Online.
One is going to be really, you have given examples coming from really high temperature sectors. And one is from aluminum fluoride, one from steel industry. So the key question now, when you look at the, medium capacity or size industries, so many, and they are also trying to do the same. Why not also targeting those specific industries for relatively smaller capacities, but modular, flexible to be able to use? Any plan for it?
It's a really good question, ma'am. Thank you for that. It's actually a good excuse for me to talk about what we have done since the demos were designed. So we realized, from what you said, absolutely true. There are so many opportunities out there that are not being exploited. And if you do the survey, you will see the biggest problem we have is the low-grade heat. That is the biggest problem. Many companies, for example, ALUFLOR, we tried one project to work together with them. Actually, it was in stream step, and they said, we love it, but we have nowhere for the heat to go. It's low temperature heat. I mean, we don't want 50 degrees. Can we have 120? The answer was not yet. So we followed, by the way, like ETEKINA had a child called iWAYS, which is now grown up. iWAYS has another child called Stream Step, which is a much larger project, which Serena is a coordinator here. And we implement, in addition to the HPCE, we implement high temperature heat pumps. The combination between the condensing economizer and the high temperature heat pump makes the majority of those cases that you were referring to viable.
So another point is, that kind of temperature level, 70 to 80 degrees Celsius, would be suitable for multi-effect thermal desalination.
So in many parts of Europe, Ibrahim, they don't need water.
No, but what I'm saying, this may not be specifically for Europe, but expanded or extended applications around the world. Middle East is going to be really, or Gulf countries would be really suitable.
For desalination applications, absolutely. Linking that with industrial plants, absolutely perfect.
And also the other point, you have been using, of course, heat pipes. And there are also heat pumps, for heat upgrades.
Yeah, that's the one. So in stream step, we have heat pipe systems that called heat pipe condenser economizers, recovers the heat low grade. So basically we get the output around between 50 to 80 degrees. And then that heat in the form of hot water goes to the heat pump, which elevate the temperature from 80 to 150 and above.
We have also filed the patents for really high temperature heat upgrade applications.
Okay.
Why? Especially for nuclear hydrogen, the current CANDU reactors are really having a kind of temperature going up to 375 degrees Celsius. But we want around, let's say, 550 degrees Celsius for a thermochemical cycle. So we have developed a heat pump with really some working fluids. That is really the key to be able to really further upgrade
100 to 500 degrees.
Yeah.
Wow. I think Nasser, you should hear this.
And
500 degrees high temperature heat pump.
And we have filed a patent for. So I am also suggesting something really you get into.
So Ryan, can I hold you to that? So in this room, we have the stream step coordinates. So that's Serena, the coordinator. We have the stream step symposium tomorrow, I believe. Tomorrow, we have Nasser, who's in turbo machinery. We have heat pumps. So I'm sure they will love to hear about this heat pump, 500 degrees.
Yeah, this is going to be very critical. That to be able to cover the.
Just 1 second.
So this is that.
Just 1 second. 1 second. Nasser. The microphone, Max. Yep.
Mic is.
What is the floor temperature? So the same temperature.
No, that's the end. That's the out temperature.
What's the temperature?
What's the
input is going to be. That's why I said 375 degrees Celsius.
Okay, so the temperature lift is 100.
And then yes, and then taking it up to 550. In the of course is really going up to 600. We need around 550 to 575. So really worked out. So that is something I would suggest, since you make it a kind of, heat pipe, heat pump, integrated solutions. So you guys keep going.
So maybe the grandchild of iWAYS can be the son of StreamStep, a much higher temperature heat pumps. I mean,
and also
fascinating.
Really consider also, the hydrogen economy, find ways to sink into.
Well, Abraham, tomorrow we have the StreamStep symposium. I'm sure we're all looking forward to your question then, because we are dealing with heat upgrade in StreamStep, which came from iWAYS. So I was checking stuff.
Give them hard time.
Well, here you are. The chair is here. Now, this shows.
Give them idea.
Well, you can see how SEEP is. Really, SEEP is like homegrown ideas just coming out. Now we have 500 degrees heat pump. Amazing. Looking forward to it. Any other questions?
Well, I mean, we look for the duel tomorrow.
Okay.
We look for the discussion tomorrow.
Sure. Tomorrow, yes.
So now is the time for having an insight, yes, I mean, for how to scale up.
Maybe just to, if you want us to take a couple of these, that'd be
Sure.
very good. Yep, thank you.
And I can ask Irina Roberts from ITC to present the exploration strategy of the iWAYS project. Thank you.
So good afternoon. Thank you for considering us to present our results. I'm going to talk about one of the work packages that is always included in any European project, which is the scaling opportunities for expanding iWAYS solutions. That's in line with the question that has been made before to some. So I will try to present today what we've been doing in reproducibility phase, and what are we doing with the exploitation strategies. Of course, we are looking forward to have many data in order to finalize the results because iWAYS project, as Sam has said, is finishing in November. So this presentation has been made by ITC because we are leading this work package that is related to life cycle sustainable assessment and reproducibility study assessment, and we are working with colleagues from Politechnika Wrocławska University, and it's aligned with another work package in iWAYS, which is the exploitation and business strategy, which the leader is Incotec, which is a Spanish consultant. So today I will try to explain what we've been doing. First, when we developed all the technologies, we thought, okay, we have considered 3 different sectors, industrial sectors, the chemicals, ceramics, and steel industry. So with the characteristics and the results from the systems, which kind of sectors they are potential for replicability assessment. So we have done a prospective study for these sectors. Then we have made some actions in replicability and exploitation. I will tell you something about this. And of course, there are two documents that we are going to work a lot with these companies that are potential end users besides iWAYS industrial companies, which is a replicability questionnaire and at the end, the technology proposal. So for the replicability, in which sectors we have focused? We have focused in two types of sectors. iWAYS sectors, of course, because the chemical sectors it's very, very broad industrial sector. There are many sub-industrial sectors that are of interest for iWAYS technology, and even for the others, for ceramics and even for the steel industry. So we've been looking for technological scenarios that are different from the iWAYS one, and of course with different geographical locations. What I'm talking is about different environmental situations. And we have considered some sectors that they have the possibility of heat and water recovery in their manufacturing process. Of course, it's impossible in the duration of the project to cover all the industrial sectors in Europe. So we choose these ones that you have here in the slide. We have this focus in the steel industry, which is an iWAYS demonstrator, but we do have many possibilities within this sector. A new one is the pulp paper industry. We have a study which kind of stages of the process and subsectors that are potential users of the iWAYS technology. Of course, cement industry is another one. Chemical industry, of course, and ceramic tile industry. Due to the time restriction for the presentation today, because I do not want to bore you a lot, I will focus in the ceramic industry. For example, and I will tell you something about the paper and pulp industry. So why is the ceramic tile industry a perfect candidate for replicability? Because you can think, okay, they have studied in iWAYS the ceramic sector, but in this occasion, I'm thinking about the other countries that the ceramic industry is quite relevant. So in our case, I'm talking about one of the most relevant industrial cluster related to ceramics is located in Spain. We are covering 30% of the world production, and we are the largest producers in Europe right now in Spain. Key considerations is geographical clustering of the sector. It does mean when a technology works and it fits to the process, we can reach a very high multiplying effect, because if the technology is working in one company, normally there is this domino effect. So it helps a lot with spread technologies. Ceramics in general is an energy and water intensive sector. Here we do have the nexus between energy and water that Geoff was talking before. And the Spanish ceramic cluster suffer a lot from water scarcity. So for us, water is quite important. There are so many restrictions now when we want to enlarge production rate, because we live in an area with over-exploitation of groundwater. So any technology that is related to recover water, for us, it's quite important. And mainly when we are talking about the spray draining process, where the 90% of the water used in the ceramic tile sector is evaporating through these processes. So any action to condensate and to recover water, for us, it's relevant. So we are expecting great results, and we do not have many data, but attending to the explanations from Sam, I think we are waiting for very good results, and let's see if we can replicate these technologies in Spain. Which are key players when we talk about replicability? For us, it's business associations. Normally, we have kept in contact with the business associations. In Spain is ASTER, which is the Spanish Ceramic Tile Manufacturers Association. In Italy, it's Confindustria, it's the Italian. It's not only ceramic tile manufacturers, it's ceramic in general in Italy. And ZPOV, the associations in Poland, as Poland is the third largest producer of ceramic tiles in Europe. Of course, it's not only the ceramic sector. For example, in Spain, we do have other related industrial sectors that I think these iWAYS technologies are quite important, such as decorating sector materials. I'm talking about print manufacturing, that is from the glass industry. This is using a stage which they are using very high temperatures and they are evaporating water. We are talking about calcination pigments that are used as decorating materials. And there are many other sectors, subsectors that are of interest, such as roof tiles, vitrified clay pipes, and refractories as well. So here is the iWAYS case study in the ceramic tile industry, where the best available techniques used in Italy is back filters alone, because I was talking that I thought it was a system that combines cyclones plus back filters, but normally in Italy is only back filters. And here is more or less what Sam has explained. We compile information about natural gas consumption, exhaust gas flow, temperature, humidity, concentration of dust, and of course other relevant pollutants that can contribute with corrosive problems. So this is the key information. So with that, we go to replicability assessment. So we have thought in a new technological scenario in ceramics. For example, in Spain, we do not use in a great manner the back filters. It's a minor percentage. Normally, all the installations have the spray drying process with cyclones plus wet scrubbers. So the conditions of the exhaust change a little bit. So I think it's a target process where we can look if these technologies are going to be useful. Here, what we have done in the prospective studies, trying to compile technical information that we will send to the technological providers, in this case to Brunel and the water treatment technological providers, in order they can assess and study if it fits for this process. Another stage of the process in the ceramics is the fight. I think in ETEKINA they work a lot trying to recover energy, but it was not the purpose of recovering water, but it's something that it's there. We have compiled many information from this sector, from this stage of the process in the table, and this is some information that is going to be treated by the technological providers. Of course, for both processes, it's quite important to look for humidity and water droplets and the presence of corrosive pollutants. This is always to keep in mind that we can condensate water, but we can remove some other pollutants that can give any problems of corrosion. So saying that, what we have in Spain, which is the country we are going to look for potential replicability in the ceramics. We do have 100 spray dryers units, which is a lot. As I told you, the 90% of the water is evaporated from these units, and we do have 305 kilns for tile manufacturing. This is something to take into account. They are located in different locations, but they are very close. If you can see the map, this area is quite small, it's below 60 kilometers diameter, so it's nothing. We do have these different technological scenarios, different best available techniques. So for us, it's complementary to what is being done in Italy. And the replicability will be conducted in one plant located in Castellón, and we will give you, or we will have results in the next months. Other sector that we have focused, it's the pulp and paper industry. I'm not really an expert on this sector, but we have tried to highlight some key technical info from this sector. Of course, for the different sectors, we have prepared and elaborated specific reports where we are compiling relevant information. Here for us, this sector is quite relevant in Europe. In the Nordic countries is located the most important producers of pulp and paper in Europe. And they have a process of steam generation with high flue gas volumes, and the focus on energy efficiency makes that iWAYS technology to study replicability is quite interesting. And here we do have a key player, which is the business association at European level, which is called CEPI. So here we have identified which are the processes with potential application, We are going to compile information for these processes. We have identified the steamboat digesting, chemical recovery, energy, and steam generation. This is true that here the temperatures are not so high as in the iWAYS process, but let's see what the technological providers have to tell in this regard. And we have the bleaching and pulp and paper drying. So we have identified different stages of the process that could be of interest for the iWAYS. Let's see which are the results. What we've been doing is to compile information, technical information that will be passed to our colleagues from Brunel and from the people from the wastewater technological providers. And let's see what are the results or their thoughts or insights about the applicability for these sectors. And another situation that can happen, and it has happened to us in Spain, for example, there is one company that has identified iWAYS project, and they have contacted us because they are interested in condensating, and we are talking about the glass wool production process. So they have a melting process and then a curing process where they are interested to recover water. So it's something that we are talking to this company. It can happen that there are more potential sectors going further than those that we identified. Probably we are going to work with this company. It's an international company and they are interested in the iWAYS technologies as well, and we can perform this theoretical prospective study. Besides the replicability analysis, we, of course, to compile information, we have prepared a questionnaire for potential customers, and we are considering, because we are going to perform the technical feasibility and the economic feasibility, and to do that is necessary to work with other colleagues from Work Package 9, which they are related to exploitation. They are working with the capital and operating costs, CapEx and OpEx. We know that this is key for the industries. They are working in the economic and financial model, and we are working in parallel with all this information. And of course, normally when you go to a company, they say, okay, and what's the environmental benefits for these technologies? That's the reason we are performing a live and social and economic case assessment for each case study, and we are trying to quantify these benefits from the sustainable point of view in order to use this to present results to other end users. And besides that, we will compile all this information and we will prepare a technological proposal to send to these companies, these potential users, and let's see how it works. But I think it's a very good baseline. And now we are compiling information, treating data. But as you know, the commissioning has finished a few weeks ago. So now what we need is many data in order to prepare all these documents and to present to the new companies. Here is the replicability questionnaire where we are asking many questions, but we have reduced a lot in order to focus directly in key questions to the potential end users and not to ask for sensible information that normally we do have problems because they do not want to give a lot of information, but at least the key, we need something in order to perform the study. And then this is the proposal, the technological proposal, which is the document that we will prepare besides the technological providers, and we will send to the end users in order they can study and see the feasibility of implementing iWAYS technology. And this task is in progress, and I think at the end of November we will have all finalized reports, and we will see potentiality in other sectors further than or beyond than the iWAYS sectors. And now this is my presentation. Thank you very much for your attention. If you want, now, sorry, I cannot give you any data, any quantified results, but I think we are going on with that. That's it. Just to the time properly. So now I think we have to continue. Now we are going to call to some colleagues in order to come here to the scenario, and let's go to the discussion table, right, Andrea? So Andrea Rubini, from Water Europe, Lois Charpentier, which is online. He will participate. Geoff, Townsend, yeah, Mr. Townsend. Jurgita from Brunel University, and sorry, I need to open my notes because I have prepared some questions for the panelists. Okay, so I will present all of them. Here with us, we do have Andrea Rubini from Water Europe platform. We have Jurgita from the Brunel University. She's an expertise in legislation related to many issues. Here we do have with us, we have seen before Geoff Townsend from Ecolab. And he has great expertise in many topics because I've seen, yeah, of course. And then we do have Andrea Abdul-Ghani from Atlas Concord, which is the technical director, and probably you can give us your industrial perspective or personal opinions in this regard. And Economiser is there from Eco. Okay, yeah, okay. No. No, it's okay. Okay, so thank you very much for all the participants. I think they are representing different fields, and so I have prepared some questions for them. But if any in the audience wants to do any question, please do not hesitate to raise your hands, and we can discuss a little bit, okay? Situation. So first of all, I have a question for Andrea from your expertise in water management. And I would like you answer me with, for example, what are the key systematic barriers preventing the market uptake of circular water technologies in industry? Which kind of barriers do you think that regulatory, economic, it's a lack of awareness by the industry, which
I guess it's a combination of barriers. I think that some of the barriers have been also highlighted today. To some extent, I mean, what I see is that we have been working for years and years in research innovation projects, I mean, like the iWAYS. Sometimes it happens that projects offer some important results, but then, I mean, there is a problem in terms of scaling up from prototypes, I mean, to real commercial or ready-to-market products. And this is a problem of, as in my opinion, of the overall system of the European research and innovation environment. But at the same time, I mean, I also understand the matter that we use public money in order to reach important results, but a low technology readiness level. And then there is the need for scaling up and calling for other kind of investment. Other kind of investments make sense when we are able to organize, I mean, important partnerships. I mean, that in order innovation to take off, there is the need for collaboration, there is the need for having common interest, and there is the need also for having this innovation being disseminated effectively. Well, something else which is sometimes missing is the capacity also, not just of the projects, but of the innovative solutions to be seen even before the market uptake, but be seen by investors, be seen by policymakers, because we can showcase that results are possible. And this, in my opinion, is one of the main barriers. Another barrier could be, and we didn't mention it, but I believe, I mean, the legislative or regulatory barriers, my colleague Loic Charpentier from World Europe. But something that I see as a potential barrier is something that we highlighted this morning during the first session. It is about the matter that we might need to invest in skills development and human capital. Well, this is something that might still be explored much better because we have, let's say, technology speaking, we have solutions, But then, I mean, when the time has come, I mean, to put the solution to be deployed in the real life environment, then we might need professionals that do not exist yet, or professionals that need to be trained, and we might not be prepared to have this kind of professionals ready for the implementation of the innovation. So this is my 2 cent contribution to this.
Okay, thank you, Andrea. Anyone from the panelists in the online, or you, for example, Andrea, from your point of view, because you are at the industrial site. So what do you think is the main barriers to scale up some technologies and to implement for water treatment? How do you see it?
Is this on? Yes. Main barrier may be barrier. System is not economically sustainable, so we love to join these projects for multiple reasons, mainly to open our mind. That we are always focused on our activities, so we have to gain money, and otherwise we die. So, but we need to sometimes to stop and think of what we're doing. And these projects, even if the results were not good this time, we are lucky the results seems to be very good. But sometimes the result is not good. But our main goal is to join to meet people thinking in a different way than we do, and talk with the university, with people from other sectors. That can be always very, very important to improve our knowledge. So I think this is the first step. Then, if the results are good, it's automatic to use the technology. If the technology gives you a good result in terms of energy efficiency, I don't think you need money from others and yours saying if the project is good, you will invest money because the system will pay you back soon. So I think the main goal for us is the knowledge.
Yeah, you gain knowledge about a technology that is a risky situation.
And I think sometimes the main error by the European Commission is to give you the solution, not the performance you have to achieve, but the technology you have to use. And this is what they did, for example, for the car sector, the automotive. They didn't say you have to save energy. They said you have to use this kind of car. I don't think this is the right way to show the way to the industry where to go. You should say, this is the goal on an energy and performance level. You have to reach this goal. That you don't have to say, this is the way you have to go.
Yeah.
I don't know if that...
Yeah, the approach is totally different. You think that we have to move to another approach.
Yes.
Yeah, my question now to Geoff, what do you think? Because sometimes from industry they say, oh, circular economy is okay, but it's going to cost more than the current situation because you need to adapt your resources to the new situation. And in the case of water, I have found with the answer always that, oh, water from groundwater from the net, it's cheaper than water treated from reclaimed water. So what do you think about implementing circularity in industries? Which kind of arguments to use to convince or to engage companies to go for this circular approach? What do you think we should do?
Yeah, thank you. It's a great question. Occupies a lot of our time. And I said, in the keynote earlier, how the value of water is really central to this, but we have to move beyond price and the unit price of water to really understand the value at a certain location. And we can have various perspectives on the value of water. We try to monetize risk, for example. There's 3 types: physical, regulatory, reputational risk, and that's one way of enhancing the value of water. But ultimately, and I touched on this briefly, ultimately we need to live within our water means. And that means that we need to really understand what's available on a truly sustainable basis and then cut our cloth accordingly. And what we see across probably about a third of Europe now is that the magnitude of water savings required is going to be in the region of 25, 30, 35%. It's really significant. And you cannot achieve that level, that magnitude of water reduction without applying circular principles. Once you start getting above 5, 10%, you've kind of exhausted all your reduce opportunities. You then into recycle directly or reuse directly wastewater. And of course, you hit technical obstacles there. You want to start using membranes, reverse osmosis, and those type of technologies. Of course, you'll have to kind of have a much different view on the way that you will plan and execute those type of projects. And of course, you cannot deliver circularity without those type of technologies once you're pursuing something like 25 or 30% reduction. So having this target in mind that I mentioned earlier, it becomes very, very important, and then coalescing around it.
We will use this kind of arguments.
Yes.
Besides other social impact that I think it's quite important, because when you avoid using groundwater and use reclaimed water, you are giving the groundwater for drinking purposes and what it should be, and not for industrial purposes. So I think there are many.
No, I mean, absolutely. The social and the environmental dimensions are so critical.
Cool.
Nature needs a lot of water. And it needs it for its own environmental health, but also business health. It's very much dependent on those healthy ecosystems. So all these things are absolutely interrelated. And the social dimension is becoming more and more important. And we see the emergence of exclusion of some communities from access to good quality water. So you're absolutely right. We have to have a very comprehensive view. Yeah.
And at this point, Judita, I think we are talking about circular economy, but I think there is some concepts that I would like to discuss with you, or you can explain. For example, what is the clean industrial deal? Because I think it's relevant what we are talking about, or what it is its potential impact on industries, and how iWAYS can contribute. There are many questions in this one question, but let's see to talk about this concept of clean industrial deal, which is there.
Okay. Thank you, Irina, and thank you for the introduction as well. It's a very good question. It is a new initiative. It was published 26th of February 2025. So it is a new growth strategy presented by the EU, and it is, I would say, really long overdue, main in EU industrial strategy, and it's coming also with action program. So the main idea is to boost industrial competitiveness. And it focuses on, that is why, why it's so important here, energy intensive industries. And also it's focusing on clean tech sector, because we obviously need innovative technologies to move that transition. So decarbonization and circularity are the two main aspects of this strategy and this action plan. And obviously, there are quite a few points, because it's coming to this action program, and then the Commission is listing make some promises what we are planning to do in different quarters of 2025. I guess there might be some delays. Just to give some examples, because I think it was mentioning as well regulatory barriers that we have at the moment. So we are trying to create this industrial decarbonization accelerator act, speeding up like permits for industrial access to energy and industrial decarbonization. Because at the moment, what we noted in iWAYS as well, that it's so different. I mean, you're not going within different countries, but also different regions we have where different regulations, and it becomes really complex for industries. Overall, the Commission admits that we currently have very complex regulations. And I think it's also, we have fragmented regulations, I would say. So it's not easy. It is not easy for industries to follow. In terms of iWAYS and thinking about water, I am quite disappointed looking at Clean Industrial Deal. I think it's mentioning water resilience maybe once in the document. So while it's focusing on circularity, I think it's lacking aspect of water reuse. And I wonder, because maybe the colleague from Water Europe will talk more, if now that we have this new European water resilience strategy that mentioning a bit more industries, I think the Commission will revisit this aspect, because disappointingly at the moment is not so much on that. Definitely on materials, but not so much on water at the moment.
Yeah, I sometimes I have this feeling that they are so focused in CO2 that sometimes other resources are like, okay, and water is really, really important. But okay, Loa Carpentier, which is online, and as Jurgita has mentioned you, so I would like to know that, or you can explain us, how does the iWAYS project contribute to the goals of the European Water Resilience Strategy, particularly in fostering a water smart economy? Could you tell us something in this regard to complement
So,
Jurgita?
Yes, and good evening, everyone. So to come back of what Edita was saying, sorry, indeed the Clean Industrial Deal was on purpose avoiding water. That was the objective also of the European Union, to wait for the water resilience strategy and to have an intergroup at the commissioner level to deal with all the water related aspect and horizontal aspect of these resources. If you see in the document, you have in fact a segment related to industry, and they set up also on the side of this strategy a water efficiency first principle, duplicating a little bit the idea that you have for the energy efficiency. The project like iWAYS and the other one financed by the European Union has, I would say, the main purpose to demonstrate how we can implement the European Water Acquis, and partly related to industrial emissions. So they had in mind the Industrial Emission Directive and the revision of the BREF, so the best available techniques document, and also to look at what is possible for the next mandate. And here, where it could be very interesting is to see how the outcome of this type of project, no matter if they fail or not, can provide input on how we can implement the water efficiency first principle. So that, I think, it's the new connection that we can foresee between the water resilience strategy and the type of the project. The water reuse regulation also could be really interesting in the sense that right now it's only limited to agricultural purposes, and we do not have at the European level beyond some recommendation in communication to promote water reuse for industrial purposes or domestic use. But you will have some challenges now also that we need to look at with the new political game that we have in Brussels. You have a series of packages, of legislative packages called Omnibus, that we will foresee in the coming months, and they aim to rationalize the current Green Deal and to simplify all the standards and partly the environmental standards. And we can expect for the fall to have something on the Industrial Emission Directive and partly on the water efficiency data collection, and or potentially also for the urban wastewater treatment management, where normally we extract wastewater for reusing purposes. So all these aspects could be very, I would say, the outcome of this project could be very interesting in this context to protect the current acquis and make sure that we keep the right drivers in the EU legislation, and at the same time demonstrate how we can implement in a concrete way. So also scaling up the project is really important in that case.
Okay, thank you very much, Laura. Yeah, I know that data are quite important because is this something that public authorities request you when we are in process of developing new legislations? They want data from industries, and sometimes it's quite challenging. In this sense, Geoff, I was thinking, what role does digital technology, because it provides us with many information and we can provide many behaviors or patterns that we do not have studied, for example, with sensors and artificial intelligence, play in increasing efficiency in water circularity? What do you think?
Yes, thank you. So, I mean, almost every aspect of water, whether it's quantity or quality, is readily quantifiable. And in many respects, the water crisis that we're facing is due to a lack of quantification, particularly in the areas where it really matters. So I believe this whole area of sensing, and of course that comes in a whole variety of forms, from discrete sensors to satellite data and such like. This whole area of sensing, data collation, data management is absolutely pivotal to water circularity, but also solving the water crisis at large. It's fundamental, and I think we'll only deal with it at the pace in which we expand the tools, the capabilities that we have in that world. And it's quite notable that reference is being made to the water resilience strategy for Europe, and the digitalization pillar is actually very strong in that publication as well. I think we need to apply a digital strategy at two levels. So one is very much at the catchment level, looking at water as a resource, understanding supply, demand, the dynamics between the two, targeting, that mentioned a few times now, what is resilience, resilient water supply, resilient infrastructure and such like. So that's very much at the macro level. And we can rely on a whole variety of different sources of information. We have wonderful platforms like Google Earth that collate that type of data and can make a lot of sense from it. So that's at one level. And then there's the other end of the spectrum, is really getting to the heart of the major water-intensive industries. I mentioned in my speech earlier about the water energy productivity nexus. It's that we need to really focus on. That's where the big impacts are made on emissions, energy use, waste, and such like. And for those applications, we really need to go back to basics, and in particular, first principle physics-based digital twins. They are highly valuable. Because it's the level of predictability of energy transfer and dissipation is tremendous, and these are very, very well understood principles. Physics, the physics behind this has been known for decades, if not centuries. So I think that is a very interesting opportunity before us. I know digital twins have been out for quite some time now, and they're being increasingly applied. But the key thing with any digital twin is asking the right questions. It's applying the correct objective functions. And the closer those questions get to what matters most over resource management, saving, circularity strategies, et cetera, the more we're going to bring these tools to life. So absolutely, digitalization is playing, but going to play a very critical role in the next few years as we try and solve these intractable problems.
Andrea, from the point of view of industry, how you see AI that plays a huge role? Can you tell us something about, if you have any experience in your plans in artificial intelligence, if this is a very useful tool for you?
Yes, we approach government, but right now I can say we use it. We have a project really focused on the AI technology. The only thing that I know of AI is that it's high intensive energy user. So the use of artificial intelligence means that you need a lot of energy. They say, I don't know exactly, but they say that we could double the demand of electrical energy to make it for the artificial intelligence to be useful. So the question is always saying, where did we get this energy? If we decarbonize, we don't have an alternative.
Yeah.
This is how to abate all the CO2 emission without finding alternatives. So we can recover all the heat that we have to recover all the heat that we can, but we need the primary energy to be easily needed to survive and to produce. So I think we should focus more on energy supply than on mainly emissions or reduction or resilience, that is always in a defense position. But we are in the real world, so we have Chinese, we have Indians, we have United States. So what will we do in Europe without energy? This is my question.
Yeah, it's a good question. Do you want any of you want to reply?
Well, I mean, without energy, also without water. So then the answer, and the two, or let's say, both of them, I mean, would be a disaster. Well, I mean, from the energy point of view, well, I mean, I think that we are on, I don't know how much, I mean, on the right way for becoming more independent in the European Union. From the water perspective, I think that we need really to run, because we are well behind the schedule. I mean, also from the point of view of the innovation. If you look at the different sectors, for example, digitalization, the water sector started with a lot of difficulties and later than other sectors. So I think that as when the world is changing quickly, we need to react fast. And from both the perspective of the energy and the water, which is a nexus that we need to consider anytime that we look at the challenge of our competitiveness.
And the last question, yeah, I fully agree with you, Andrea, but for example, bureaucracy, it's something that, okay, we are faster with technology, we have ideas, we have projects, but then we go to the public authorities, we give data and stop. Bureaucracy, what do you think about that, Jurgita? Because what do you change if you have the possibility to change something from legislation in order to speed up these processes of implementing these new technologies?
It is a good question, Irina, and it is not an easy to find an answer. I guess, you know, you have to look at the EU. It's a rather complex decision-making mechanism that we have, and it is, you know, not easy to pass legislation. You have obviously EU institutions, you have the member states and their interests involved. So it is quite hard, and we can see the Commission also. It is political club. So, like, you know, if we're talking about this water regulation, that first of all it was mainly focused on agriculture. We can see now that we are trying to go beyond agriculture because it's coming from member states, and they were looking at member states, and I guess you need to have both bottom-up and top-down approach. Top-down in terms of strategies, because you need that security from you know, investors' point of view. But bottom-up, you need to listen to industries. You need to listen to people, and then you have to make it happen. Because what right now we're seeing is bottleneck effects. That regulations create. And usually, I must admit, I'm a lawyer, but I must admit that law lags sometimes behind innovation. And we need to speed up process. So hopefully, because the Commission is acknowledging that, so hopefully we will see some changes, because we can't have like taking 5 years to introduce new regulation, and then, you know, by the time the regulation is out, it's already out of date. I think.
Okay, so I think we have to close this panel. I do not know if from the audience someone wants to make any question.
Actually, a question for the whole team, me included somehow. We're dealing with a new technology that iWAYS created. I know from replicability analysis point of view, it is a challenge, something new. From policy point of view, there are certain countries where you can't emit the exhaust if it is lower than 150 degrees for various reasons. One of them is protecting the stack, for example. So this is more on the policy legislation, something that we have to change now. And also from national point of view, each country in Europe is dealing with these aspects differently. Now, what are your thoughts? What is the next step for us? Now we have proven the technologies in iWAYS successfully. I don't think there is anything we haven't achieved in the project from what we promised in the proposal. Where do we go from here? I mean, the technology part is done. What is to follow?
From my point of view now, the European Commission has created what is called Insight. Okay, this is a new research. Okay, it's a platform, I would say, which is beside the JRC in Seville, in Spain, and they are working with these kind of technologies that can be considered as emergent ones or new ones, and they are developing this map of technologies. So I think a good idea is when you finish this type of project with some technologies that are proof that they are working properly in several industrial cases, you have to prepare robust technical information. We have to fulfill a questionnaire and then send to this Insight, and they are open to give visibility of this technology at European level. I can't tell you that because I'm involved in BREF, review processes, and from Insight they are pushing quite a lot, and I've been talking to them in Seville, and I think this is a good opportunity for those research projects that are developing technologies. It's quite interesting because they want to follow up these emergent techniques, because if not, these kind of techniques are forgotten in a box, and we do not. We see emergent techniques in BREF, in many BREFs, but you never know how is the progress. So now they are going to follow up with these technologies. I think this is one of the possibilities to keep going with this emergent technology.
I was going to make a very similar comment, actually. So just adding a little bit to that. I mean, in your presentation previously, you highlighted the industries that you're going to focus on. And, there are energy-intensive industries for sure. There's a water intensity element to them as well. I mean, that opportunity mapping, not just at the macro level, but at a small system level as well, the sub-system process level, are really worth pursuing, and then modeling to really get the confidence levels up that you can actually deploy this at scale. But I think from what I've heard today, and it's a very exciting introduction, I think there's a lot of interest. I could easily take, your outline presentation to a lot of industrial customers, and these are super hot topics. And, waste heat integration, the value of waste heat, valorization, you know it better than I do. These occupy a lot of time in industry, so very much on the right tracks. And case histories, of course, as we heard this afternoon, they really bring these initiatives to life, so that the stronger the case histories, the better supported they are with metrics, and the quantifiable return on investment, of course, a really important metric that sits at the heart of these discussions. The more that's available and communicated, better. Yeah.
Thank you for the question, Sam. From the legislation point of view, as I said, Commission clearly now acknowledge these complex regulations, and I believe for the member states, if we have like national barriers, creating all these regulatory barriers, I think once they will come to meeting the targets, because we all know the EU has binding targets, and all member states, they have to contribute to these targets. Once we realize that actually they are not contributing enough to these targets, the Commission can start litigation against member states with the court involvement. So once we start paying penalties, we will start thinking maybe we need to change national law or even local law to facilitate. And in terms more specifically for water efficiency, we can see right now that the Commission is planning to launch a pilot project to promote water efficiency, including like closed water cycle technology, and it will be focusing on some selected industrial clusters. So it's coming 2025, 2026. So potentially that is, I can see a great opportunity for the iWAYS project to go forward. Thank you.
I mean, can I just follow up? Maybe Andrea will be my target here. From the company's point of view, Andrea Atlas Concord, just to be distinguished. I know how hard it was to get Atlas Concord to be convinced when we started the proposal, and then because of your previous experience, you had some trust in the group. I can only imagine if I came to you out of the blue and said, look, we have this technology, can you implement it in your company? Your answer may be straight away, sorry, no, we're not interested. Now we have achieved this with your support as a demo case. What is your advice to us when we approach other companies? I mean, we managed to basically show the ROI is very reasonable. We successfully demonstrated the technology of the iWAY project. What is your advice to us? How should we approach other energy-intensive companies? What shall we do? Focus more on the water recycling, more on the waste heat recycling, or maybe both?
It's a very difficult question. I mean, to get in the same goal, in the same situation, to get the energy recover and the water recovery is very difficult, and sometimes one is against the other. So I was thinking before the other speech, talking about the breath that are coming for us. There are very difficult problem, because if you fix the pollutant, you want to a very good target for environmental issues, so NOx, SOx, and so on. You usually have to spend a lot of energy to abate, to have good results. For example, wet scrubber are very water intensive for the consumption. So every kind of emission control means you need energy. So the breath targets are, you have to be energy efficient, but you have to lower the emission. In the same way, sometimes it's impossible. You know, for example, in the kiln we use RTO, that is very energy intensive. So you have a very good emission level, but you have a very low efficiency, because you have 5%, 10% more consumption on the kiln. So it's very difficult to balance environmental aspects with energy efficiency aspect. And it's very difficult to get them together in the same way, saving money, and it's very difficult. So it's difficult to give you suggestions how to approach the way. I think if the Commission, the European Commission, gives the target too good to achieve, it will be counterproductive. So we will stop the manufacture, and someone in the world will do our job in a not in a better way. So I think we have to search the balance between environmental aspects and energy efficiency, so that we can achieve them. So otherwise we close everything and we go abroad. This is a huge problem, I think.
No, normally in this case, when industries has approached us, they are always asking about the condensation water. This is what is more, it creates more curiosity between industries when they have approached us.
One last request is, yes, the heat pump that you mentioned before, we have a huge amount of energy at 80 degrees, 90 degrees, that is very difficult to use. If we had this heat at 120, 150 would be very, very, very useful for a lot of processes.
So we have a market with a stream-step system now. Fantastic. We'll approach you first thing.
Yes. And also the water recovery. The water is not very expensive on the money point of view for in Italy, for example, but it's we have limitation for the water from the ground. And I think it's very important to use the water in the best way we can.
That's the reason the European Commission is establishing key performance indicators for water consumption. So
this is against what they ask for the environmental control.
Okay, so thank you very much, all of them, and we keep continuing with the other speakers. Yeah.
Thank you. Thank you so much. Thank you, Irina. Thank you, Lisa, Geoff, Andrea. Thanks a lot. Thank you so much. Now, we have a small change in the schedule of the event because we are let's say postponing the closing keynote from Alan Mestert, and we allow now the projects, the new projects, let's say following the results and the wave of the iWAYS project. There are new 3 projects that comes from Horizon Europe, funded by Horizon Europe, under the umbrella of Processes for Planets. And we have 3 projects that are 3 sister projects coming from the same proof of proposal: Resurgence, Cornerstone, and Revolution. And today we have 3 representatives of the project. They will give you the insights of the project, showcase what's the project, the ambitions of the project, and the expected results. And I invite the first one is Resurgence, Dr. Sfeia, coordinated by SETIM, and she is online.
Yes.
You're welcome to take the floor. Thank you.
Thank you, Andrea, for the introduction. Hi, good afternoon or good evening, everyone. I'm Xuefei Yang from SETIM Technological Center. We are the project leader of Resurgence. First of all, thank you for the invitation for the iWAYS final conference. And it's a pleasure to be here today to introduce Resurgence, Horizon Europe funded project, which is promoting greener and more efficient industrial water management across Europe. Next slide, please. Well, Resurgence is a 4-year project running from December 23 to November 27, with a total budget around 9.2 million euros. Next slide, please. Well, we are proud to coordinate this initiative from SETIM, based in Spain, and we are working alongside 18 partners and 2 affiliated entities that include universities, research centers, technology developers, and big industrial players across Europe. And we also have a strong international component with a chemical industry partner from Turkey and the collaborating university from Pakistan. Next step, please. The main objective of Resurgence is to boost the transformation of European process industries into wastewater resource recovery facilities, which means moving away from seeing wastewater as a burden and turning it into valuable resources. So this aligns directly with 3 of the EU's key 2050 objectives, which are achieving climate neutrality, advancing circularity, and strengthening the competitiveness of EU industries. To achieve this, we are focusing on 4 seeds for circularity. These seeds represent pilot ecosystems where we integrate modular, flexible water treatment technologies and advanced digital tools to maximize the recovery of water, energy, and valuable feedstocks from industrial wastewater. Next slide, please. So as mentioned, one of the core concepts of resurgence is the seeds of hubs for circularity. These seeds are not just pilot sites, they are strategic foundations for building future hubs for circularity, in which are industrial ecosystems that foster industrial symbiosis and even industrial urban collaboration. And by connecting different sectors and regions, these hubs can really help accelerate the green and digital transition of European industries. Next, please. And to bring this concept to life, we follow a methodology structured in 4 main stages. The first one is the R&D of innovative technologies at lab scale, including water treatment technologies and digital tools. And the second one is the integration of technologies and pilot demonstration, scaling these solutions to TRL6, integrating them into real industrial settings. And the third stage is the promotion of seeds for circularity, turning pilots into seeds for future circular hubs. And the last stage is the maximization of replicability and scalability, ensuring the solutions are transferable across sectors and regions. Next, please. Now let me walk you through the core technology innovations we are implementing in Resurgence, grouped in 4 areas. The first one is water recovery. We are developing innovative technologies, including reverse and forward osmosis with biomimetic membranes and nanostructured membranes for membrane distillation, as well as advanced electrochemical technologies. Together, these aim to recycle over 20,000 cubic meters of industrial wastewaters back into processes during the demonstration. And the second one is energy production. We are using salinity gradient energy through reverse electrodialysis and capacitive deionization. We're producing biogas with anaerobic bioreactors. We are also generating hydrogen via dark fermentation and electrolysis. Last, we are recovering waste heat with a novel rotating heat exchanger. And with all this combined, we are targeting a 30% net energy reduction in all the cases. And another big focus is turning waste into feedstock. So across our pilots, we aim to recover around 12 different valuable materials, from cellulose, biopolymers to phosphorus and the critical metals. And finally, we are integrating digital innovation, including AI-based decision support tools, digital twins of treatment systems, and real-life monitoring using innovative sensors. The main goal is to make operations more efficient and to reduce the utility cost by over 20%. Moving to the next slide. Here are the case studies. All all the technologies mentioned are being investigated and will be validated in 4 real industrial case studies. The first one is Navigator, a pulp and paper industry located in Portugal, working on water reuse and recovery of cellulose and lignin and biopolymers. The second one is Organic Kimya, a chemical industry located in Turkey, focusing on water recovery and improving latex and the polymers recovery efficiency. Sorry, the last slide. And the third case is Celsa Poland, a steel industry located in Poland, treating high salinity streams to recover water and also phosphorus and metals. The last case is urban industrial symbiosis. The responsible is Aqualia. We are creating integrated models that connect municipal and industrial systems to recover water, energy, and nutrients together. Yeah, now the next slide, please. So beyond technology, resurgence is also about impact and long-term sustainability. For example, each partner is identifying exploitable results for spin-offs, joint ventures, and licensing, etc. And the robust dissemination and replication strategy ensures our scalability and engagement with new stakeholders. So our exploitation pathway is designed mainly in 3 phases. The first phase including share results, protect innovation, and build a strong foundation with life cycle assessment, life cycle costing assessment, and business planning. In the second phase, we will focus on scale up, launch pilot hubs for circularity, and expand into new settings through partnerships. In the third phase, we will bring resurgence innovations to the market with proven business models and investment strategies. So I think this has been a quick glance at resurgence, and the next slide shows my contact information as the project leader if you'd like to connect or know more about the project. Thank you very much again.
Thank you so much, Zoe. It's by the way, I'd like also to share with the audience that all the Europe is a partner of this project. And now we give the floor to the cornerstone projects. Sena Quist-Jense, coordinator from the Aalborg University.
Yeah, so hello everyone. As Andrea was telling, my name is Jasna, and I'm from Aalborg University, and I'm coordinating the Cornerstone project, which is called Combined Technologies for Water, Energy and Solute Recovery from Industrial Process Streams. And first of all, thank you for inviting me to this session today. I've been following the entire iWAYS conference this afternoon, and I think it's of great interest, and congratulations for the results that you have obtained. It's very, very important and also very interesting for me as a coordinator of the Cornerstone project. So I'll just go or give an overview of the Cornerstone project. We are 16 partners from 8 different countries. We have a project budget around 10.5 million euros, and it will last for 4 years. We are already 1.5 years in the project. We started in January 24, and we focus on 6 different treatment modules, as we call it, and 3 case studies, and this I will come more into detail with. This is the consortium of the Cornerstone project. Here you can see how we are distributed across Europe, and this picture is from the kickoff meeting. So we are different large enterprises, research organization, SMEs, and so on. So quite a broad range of different expertises. The overall objective of Cornerstone is to obtain circular economy through recycling and reuse of different resources. And when we talk about resources in the Cornerstone project, we talk about water, we talk about energy, and we also talk about different solutes that are contained in the wastewater streams. So the concept of Cornerstone is based on 4 different components, and component 1 is related to different treatment modules, the technologies. And here we focus on different membrane technologies, for example, nanofiltration, membrane distillation, membrane bioreactor, electrodialysis, and membrane crystallization, and then also a heat exchanger technology. So these treatment modules we test individually, but we will also integrate them to obtain the best possible solution for water, energy, and solutes recovery. We have a component 2, which is related to digitalization. So we have different sensors and smart monitoring, and we will use AI to optimize the technologies and the monitoring to see how we can best operate it. And I really followed the discussion on the AI today. It was of great importance on how we should actually, AI will use a lot of energy, it will also use a lot of water. So how can we actually also incorporate that into our project? And then we will also do digital twins of the processes. And then the third component is the demonstration sites, where we focus on 3 different industries: the steel industry, the pulp and paper industry, and the chemical industry. And then as a 4th component, we have transversal strategies, where we have sustainability assessment. We have exploitation toolboxes, which includes decision support tools. So how does the industries take the best decision on their recycling strategies? And then, of course, communication and dissemination also as a part of this component. So this is the concept of the Cornerstone project. We have different objectives. So we will test, advance, and optimize the different treatment modules in combination with the existing industrial processes. So we are testing on real wastewater. Then we will use smart monitoring tools for digitalization and intensification of the processes. We will integrate the different treatment modules and the digitalization into the Cornerstone systems for the 3 demonstration sites. Then we will do sustainability assessment of the Cornerstone solutions, and then we will develop these decision support tools to improve the water, energy, and resource stewardship in the industries. We have some very ambitious targets. We would like to reduce the wastewater quite a lot. We would also like to reduce the carbon footprint, even it's very challenging when we introduce new technologies. And we, as far as possible, aim for 0 liquid discharge. So very ambitious, but this is the ultimate goal and the impact that we wish to obtain for the Cornerstone project. Again, with the different treatment modules, we have 2 modules that are connected to energy recovery. So we're using non-clogging heat exchangers for thermal energy recovery. And then we are looking into anaerobic membrane bioreactors for the chemical energy. For water recovery, we include nanofiltration and membrane distillation So a pressure-driven membrane process and a thermal-driven process. And I could see that also in iWAYS, you have also included membrane distillation. For solute recovery, we look at bipolar electrodialysis, for example, for acid recovery, acid-base recovery, and then membrane crystallization, which is just it looks like membrane distillation process, but we just run the process until we have removed so much water that the salts or the minerals in the solution starts to precipitate. So these are the 6 different treatment modules that we have, and then we will integrate these different technologies so they fit the industries in the best possible way. So for the system demonstration, we have the 3 different case studies. For the chemical industry, we have Covestro involved, where we focus on chemical energy and water recovery. For the steel industry, we have HKM, where we focus on energy, water, and acid recovery. And the pulp and paper industry, we have ESCI involved, where we focus on energy, water, acid, and sulfate compounds recovery or other minerals recovery. And a little bit again on the digitalization part, so the sensors and the smart monitoring and the digital twins. And then, of course, we will validate these findings using our real data that we have also obtained in the project. And then the decision support tools, not only on water, but also on energy and the other resources in the waste streams, and then the sustainability assessment in the environmental, social, and economic line, and then again communication and dissemination. Just a little bit more on the sustainability assessment and where we are now. We have just made the baseline of the LCAs. So we have looked into the industries and how they exist today, and looked into the baseline of the industries. And now we will then move further on to see that when we actually have the different technologies incorporated as the cornerstone systems, how can we improve or how will then the LCAs be and LCAS? Yeah. And as the last part, we have this on the decision support tools that I really find very interesting. So what we have done now is that we have looked into the current state assessment of the different industries, and we just published a short report where we have conducted a survey of more than 40 industries to see the current state assessment. And then the next task is to look into some decision support tools for the industries for the water stewardship, and also the data management of the industries, and then on the resource recovery. So how can we actually help the industries to take a decision on how to best recover water, how to best recover energy, and the other resources in their waste streams. And I think this was the overview of the Cornerstone project. So yeah, thank you for your attention. And this is the Cornerstone website, and you're always welcome to reach out to me if you have any questions. My email is just here. Thank you.
Thank you very much. Thank you. Thanks a lot. And now is the time, for the last sister project. So it's a revolution. So I welcome Tamara Leon Oviedo to take the floor. Thank you.
So first of all, good afternoon, good evening, and sorry for all the inconvenience. It's always tricky to get this online conference. But anyway, I'm Tamara Leon. I'm coming from Setacqua. which serves as the project leader for Revolution. And I think many of the things that I'm going to talk to you has been already said, but it's also really interesting to be here. And thank you for the invite of being part of the iWAYS Final Conference. I'm going to start saying what Revolution is a revolutionary approach for maximizing process water reuse and resource recovery through a smart, circular, and integrated solution. Next, please. Okay, so I'm gonna just give you some notes briefly about what is ETEKINA. We are a network or water technology R&D centers, and we're based in a unique public-private collaboration model. So we offer R&D solutions, and we would like to ensure that the entire water cycle is efficient at all stages. So we're really committed to the local area, and we have different sites within Spain. Actually, we have 4 that you can see here in the screen: Galicia, Andalusia, Barcelona, and Valencia. And we're really focused on addressing global challenges, ensuring economic, environmental, and social growth. And of course, we also have a site in Latin America, which is Chile. Next one. So just quickly, we focus on 5 strategic areas of innovation. These 5 you can see here in the slide, and these areas are aligned with the Sustainable Development Goals promoted by the United Nations. And Revolution fits in the second one, which is production and new resources. Next. Okay, so now I think it's the time to give you some context of what is the motivation behind Revolution, and I think maybe is behind this conference and many of the projects that we have heard before. And these 2 words are really familiar for everyone, which is water scarcity. I will give you some numbers just for you to realize how important to address this is. So water stress affects 20% of Europe's territory and 30% of population every day, and is likely to increase in the future due to climate change. So what we do now is to manage the existing water resource efficiently and respond effectively to the current water challenges. So with that in mind, next. What's going on with the watering industry here in Europe? So 40% of the water used in industry comes from the abstraction of fresh water. So that means that we will have several industries with high consume of fresh water. We will have complex effluents to treat before discharging them to water bodies. That will increase cost. We will have environmental issues, high expenses, and we need to take and improve opportunities. How? Through innovation, moving through a zero liquid discharge. And this is kind of the motivation we have behind Revolution, and I think behind all our brothers projects that have been presented before. And here I have a table presenting one of the several intense water consume industry that we have, and that have been already presented, that are paper, steel, and gasoline. Next, please. So what are we? Revolutions. We are 20 partners, 9 countries with a 10.9 million budget, working for 48 months. We already 1 year and a half, and we also a funded Horizon project. Next. And here I would like to address all the consortium. You can see that we range from universities, technology centers, and also industrial partners are really important for our goals. Next. Okay, so now that you have in context what's the motivation, let's state about the 4 key objectives that we have. So the first one is design membrane-based wastewater treatment trains for 4 things: water and heat reuse, removal of hazardous substance, and solid recovery. The second one will be develop novel membrane materials. I mean, we're not going to be restricted to use only commercial membranes. We're going to do some developing here, and we're going to assure that these membranes will be integrated and functionalized within our processes. The third one is develop a smart digital tool. So we're going to back in AI for any decision support, risk management, and process optimization. And the last one, and this one is for me the most important one. We're going to demonstrate our toolbox in 4 industrial sites. Next, please. Okay, so the demonstration sites are the following: from petrochemical, bio-based, steel, pulp and paper. And you can see that I put these 4 industrial partners next to the academic or central technological partner because they are working in synergy, because we want to achieve really ambitious KPIs. So in terms of water use, we would like to go up to 90% of water use. Regarding heat recovery, we're going to range from 50 to even up to 95 heat recovery. And regarding the solute recovery, we're going to recover some organic fraction, filler, hydrochloric acid, sodium hydroxide, ammonium, all of this in the sense of challenging the water scarcity and the water stress. Next. Okay, so now that you know what we do, how are we going to do it? And this is the methodology where we have been following. The first, as I said, is design a wastewater treatment train. So for that, we need to characterize some wastewater streams and wastewater heat. Can you pass the animation? Click, another one? Okay, it's good. So you see again the names of our industrial partners. We got from them 16 industrial wastewater stream characterization that will fit all the studies that we have and will lead us to select the membranes and technologies appropriate for each of them. And of course, that will lead to the design of pilot plants. So it's important to state that the pilot plants is going to be sited within the physical industrial partners. So that will extend the scope of the analysis and will give us more representation of the results. Next. Okay, so the second one, as I said, is develop novel membranes materials. So the first one is a nanocellulose-enabled membranes, which is really good because as a biocomposed membrane is easy to manage the old membranes because it is also a concern for every membrane operation. We're going to functionalize some ceramic membranes for filtration, and we're going to do an advanced membranes optimized operational regime for membrane distillation because this is one of the technologies that we include in the membrane trains that still need some push-up. Next. Okay, so as I said, we're going to develop the smart digital tools. What are we doing already is developing digital twins using machine learning model for control and optimization, explainable AI for better understanding of the generated knowledge. And this is really important, digital process assistant tool to enable decision making. Next. And once again, I want to highlight that the 4 demonstration sites come from 4 different industrial sectors, and they're going to be located in 4 different countries. Next, please. Of course, we like to communicate and disseminate our results. And next, because our final goal will be to replicate solutions in real life. Next. Okay, so with all these methods that are the digital tool, the wastewater pretreatment and filtration solutions, and the resource and recovery strategies, what are the outcomes that we expect from our project? And these are demonstrate sustainable industrial water consumption, enable a fully circular use water in process industry, support a techno-economic feasibility, and of course this is important and backed with the construction of the pilot scenario, well, the pilots at the physical scenarios that we have in the industrial partners. We're gonna recover substance and energy from wastewater. And of course, we would like to contribute to EU climate neutrality goal. And last. Okay, so just to finish, I already stated that we have 1.5 years already of the project. So what we have done already is the characterization of the streams and the baselines. We already select some membranes and systems, and we're currently developing membranes, testing it, designing treatment trains, working at life scale. But what is important is we are already in the phase of construction and commissioning the pilot plants to be at the industrial sites. And in the future, we would like to demonstrate our technologies and solutions at the demo sites, not only technically, but economically and environmental and social impact assessments. Next. And that's all from us. If you feel that you have any comment or question regarding Revolution, please, would like to hear from you. And thank you very much again for the invitation.
Many thanks, Tamara. Crystal clear. I'd like to take the opportunity for pre-announcing that we have a clustering event in December for the 3 sister projects that will be in Brussels, back to Water Knowledge Europe. And well, now I mean we are really at the end. I think that thank you so much, Alan, for being so patient. But it's an important closing keynote, which is about what should do finance for industry. It's a question, of course. You're here for that to respond to this question. Thank you, Alan.
Thank you very much. You can put up the presentation. So my colleague Geoffrey said it was between you guys and just after lunch, or between you and I guess breakfast at this point. So my name is Alain Mestar, originally from Luxembourg, and I co-lead at Water Europe the Water and Finance Expert Group. The co-leader with me is Magdalena, who is, thank you very much, who is actually the former Minister of Finance in Poland. And what is quite interesting, we're actually 18 experts from different parts of Europe and different parts of industry. So we have water specialists, we have academia, we have researchers, we have a few bankers, and then you have me as a former investment banker. What am I doing in that group? Well, I'm the one in that sense who has some of the practical experience because I've been investing in a number of clean tech companies since 2008. And water tech has been my main focus. So why do we need to act now? I mean, here is a very well educated, very well informed audience. You know exactly what the problem is, but the problem is actually not even here on the slide. The problem is even bigger than that. It's actually the water risk. What happens if not enough water is available? One of the big issues is water is a big use, so everyone relates to water, and water is granted. So nobody thinks of water as a strategic asset, and now especially with the EU as a competitive advantage. We all remember 2022 when the situation in Ukraine developed. Suddenly energy was on everyone's board, and then water suddenly disappeared. Why? That is one of the issues because energy is a quantifiable, let's say, a commodity from a price point of view. So, as I mentioned, water is actually taken for granted. It falls from the sky. So in that sense, why should it cost anything? It's not seen as a strategic commodity. The big issue is quantifying the actual business risk of not having actually enough water. Imagine some of the high-tech industries, in particular, for example, utility. We talked about paper pulp, we talked about steel, we talked about aluminum. All of those factors, all of those productions actually do require a substantial amount of water. If there's no water, no production. The other problem as well, which I have ultimately as an investor, is that water for now is not really very sexy because there's not a price attached to it. One of my companies is actually able to reduce 50% of water usage within cooling tower processes. Well, in some parts of the world, water doesn't cost anything. So if I say 50% of nothing, Well, I don't get a return on investment, and I might as well put my money elsewhere. Long payback periods and high upfront costs. One of the big things I'm sure you'll understand very well, bankers are not patient. So patient money is not with bankers in that sense. We want a return on investment, the lowest risk possible at the highest return, and water does not necessarily fit the bill. The other issue we had, the lady before had mentioned about complex regulatory environments. Yes, we are the EU, but we still have in every jurisdiction and in every country regulation which is not necessarily the same one in the neighboring country. And that creates, of course, a problem for scalability. If I want to scale my water business, I want to make sure that I'm dealing with the same rules and regulations anywhere. So my stake is that industry should be the drivers. They should be the enablers. Why? Because industries are the ones who are actually looking for return on investment. Industries are the ones who are going to be penalized if they do not comply with rules and regulation on the water side. So the industries are the ones who can actually lead the change in reducing water usage. And then water will become a strategic asset. Here I'm saying that water needs to be priced not just in cubic meter, but in business continuity terms. We've seen what happened a couple of months ago in Spain, Portugal, and southern France. Well, yes, maybe it was not water related, but imagine that the same issue would happen actually if not enough water would be available. Imagine what actually would happen with you using your computer and your phone right now, because all the data you're utilizing now, where is it going? It is going to a data center, and a data center is actually using a lot of water. Somebody else mentioned AI. AI is a huge consumer of water, especially through the cooling process. If no cooling is there, you're not going to have any AI, you're not going to look at your computer and your phone tonight. So at the level of the expert group, because we work very closely, of course, we're part of Water Europe, we work very, very closely with the Commission. And based on the EU Water Resiliency Project, the Green Deal, we actually developed a number of priorities which we feel are quite important in sense to look at the 6 different pathways. So here you have a number of pathways. I think what's important is you have to divide them in both financial and political, because there's not going to be a success on the financial side if you do not put a strict political framework for everyone to understand. The EU is very nice. It will give you a framework, but the actual work will have to be done by private capital in conjunction with public capital, such as the European Investment Bank or the European Investment Fund. So de-risking is quite important. So if I invest in a project which has a longer time horizon, let's say 10 or 15 years, how can actually I make sure that that project has a risk which I or my investors can live with? That's one of the issues we need to discuss with the European Investment Bank in terms of doing blended finance and doing green bond or blue bond issuances, in terms of doing public-private partnerships. Clarify and monetize water risk. Well, unfortunately, we've seen what has happened with the CSRD, with the omnibus. Suddenly, all of this, sorry to use that word, has been watered down. So now, again, water is on the backlog of the priorities. The lady before mentioned that, unfortunately, water is not enough identified as a clear risk for Europe's infrastructure and economic development. When I say here demand-side regulation, is that we need to make sure that at European Commission level, that we have clear rules and regulations. We already see that, for example, for data centers, that they are benchmarked in terms of energy usage. They've started now the same thing with water, but it actually should be at every level of every industry. And several times, a couple of ladies and gentlemen mentioned here that they were able actually to reuse 95% of wastewater. Those should be actually standards which oblige companies to actually reutilize any wastewater which can be treated adequately. So policy recommendations. So it's very, very important that at the EU level, that we now clearly are able to integrate water within the EU taxonomy, within the CSRD. We have to have clear water reuse regulation, which goes hand in hand with the wastewater treatment directive. It's not possible anymore. Unfortunately, Geoff is not here today. It's not possible anymore if you have technologies which can actually alleviate 100% of chemicals, for example, in cooling processes, that you cannot consider that technology as best technology available. Again, somebody else mentioned the InSight project, which I know in and out, and I can tell you, even if you have a breakthrough technology, it is very, 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 very difficult in order to get in there. So even if you have a breakthrough technology, in order to reach those levels, even at an EU level, my water company I represent has 22 people. We do about 20 million euros in revenues, but we're still too small in that sense to be able to make an impact at EU level and unfortunately to be taken serious. Industrial Emissions Directive, I'm not going to go into detail. Minimum water efficiency standards for industry. I give you an example of what that entails. We have been involved in a project which is next to Maastricht. Maastricht has about 50 kilometers from Maastricht. You have a project called Camelot. Camelot is actually the largest chemical production site in all of Europe. 40% of all chemicals in Europe are produced in Camelot in the Netherlands. What is happening? 65 companies are now about to lose, imagine that, about to lose the license to operate because the Dutch government has said, this is enough. We cannot work this way anymore. You guys are polluting the whole process. We were one of the companies, we won the tender, but again, it's going to be an upward battle in order to get, hopefully, where we think we could get. Financial recommendations. So, Water Transition Fund, a lot of people have been talking about, again, to use analogy, a lot of water has gone through there. It has not seen the day of light as of yet. When I say blended finance is private-public partnership, you all have heard green bonds. Luxembourg is clearly the largest world center for green bond emission, but we have not seen blue bonds, i.e. projects which are purely financed on the merits of actually saving water. On the merits of saving water, we need to promote not just public-private partnership, but also ESCO models, or water as a service. There is hardly any company in Europe who's actually providing a solution where actually water as a service is clearly being identified. And what I stand for is really prioritize SME support and water as a service model, because there is so much talent in Europe. There are so many companies in Europe. I know a couple of individuals here are looking and are working with talented smaller companies. But then again, the question at one point Sam was asking, how as a smaller company can I actually be successful and scale? The issue of scaling, you can have the best idea in the world. If you do not have the finances to do it, it's still going to remain only one of the best ideas virtually. So call to action from strategy to investment. So my stand on this, that's me speaking, not Water Europe in that sense, is that industry have to act in terms of putting policies in place for water reuse and water efficiency. That is the only way, ultimately, we're going to have a resolution. I mean, some of my friends within the, let's say, the desalination industry, I'm not necessarily a big fan of desalination because desalination is very expensive, is environmentally not sustainable. So for me, why go and look for new water? There is plenty of water. You just have to make sure to utilize it in a much more let's say, a prudent manner. And if you can actually, as some projects, Sam's other projects here, actually can reuse 95% of that water in a circular system, then you do not need this huge desalination project. I can understand in some parts of the world it makes sense, but not everyone should see that at the final solutions. Policy must create conditions for investment. That's not part of my remit, but there has to be an incentive schemes in order for investments to flow towards water projects. So together, once we turn the policy to bankable water project with the help of institutions like the European Investment Bank, and I'm happy that we have actually within our water Europe Water and Finance Expert Group, we have actually two individuals from the European Investment Bank, Waldemar, who is originally from Poland, and Edouard, who is originally from France, but he actually happens to be the head of water at the European Investment Bank. And with individuals such as that, we very much hope that they can also foster the agenda. Ladies and gentlemen, thank you very much for your attention. And I'm not sure if there's a drink, but I want to thank you.
Thank you, Alan. Thank you so much. And this is also in a playbook. It's gonna be published in a few months, right? About what can we do about it.
Correct. So basically, the task of the expert group is we wrote a white paper, which happens to be available on the internet. And the idea is actually to do a playbook. So the playbook is actually an actionable process. It's nice to, writing white paper is a nice intellectual exercise, but I'm a more kind of, let's say, to-do guy. So what can we do? We have a problem, we have the solution, and now we actually have to bridge in order to make those solutions effective.
Thank you. Thank you so much. So we are closing now. I think that I'd like to ask Sam, Elmar, it's time to do the final notes about this. I say long but amazing day. So
perhaps I wish Luca was here. Luca, who is the coordinator of iWAYS, he sent his apologies. He made a plan a year ago that he couldn't really change. So on his behalf, on my behalf as technical director of the project, I thank everyone for being here today. It is our final conference for the project, but hopefully the first of better things to come as an outcome from the project. So I thank every one of you. I thank all the partners. And more importantly, I thank you, Elmar, ESCI. Thank you, Andrea, Water Europe. You've done an amazing job to make us look good. So I hope you will all join me to thank them.